All right. We are so excited to have Pamela Weber Harris here. This has been an event at least 18 months, if not closer to 2 years in the making. So thank you, thank you. I'm glad schedules aligned. Um, but Pam is really changing the way we view and teach mathematics. She has authored several books. She's a mom, a former high school math teacher, university lecturer, and as an author, she believes everyone can do more math when it's based in reasoning than math as memorizing and mimicking. All of her roles have said that. Pam has created online Building Powerful Mathematics workshops and presents frequently at national and international conferences. Her particular interests include teaching real math, building powerful numeracy, sequencing rich tasks to construct mathematics, using technology appropriately, smart assessment, and vertical connectivity in curricula in schools PK-12. Pam helps leaders and teachers to make the shift that supports students to learn real math because math is figureoutable. Without further ado, I will hand it over to Pam.
Thank you so much. I was driving home and I was thinking hard. Do you ever drive and you kind of almost don't even pay attention? Yeah, I was concerned. I just had a conversation with my kids' teachers and they said, "Hey, Pam, we're getting the message loud and clear that we need to stop giving kids math anxiety. So stop giving them timed fact math tests." Well, we don't want to give kids math anxiety. So we stopped giving them timed fact math tests. But now we're noticing that kids don't know their facts anymore. Is that important? As a high school math teacher, I was like, that's important. But just like you, I also don't want to give kids, adults, math anxiety. So I was fussing. I was thinking hard. Have we thrown the baby out with the bathwater? I'm thinking hard about this. I drive through my neighborhood, drive in my driveway, walk in my house, smell a double fudge chocolate Pop Tart. That means my kid's home. And I was like, hey, 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 you're like in fourth, fifth grade. I ask myself, I'm thinking, do you know your multiplication facts? But what I asked was, I just chose one out of the air at random. And I said, do you know your fives? I'll never forget. He looked at me, calm, said, no. Math teacher mom, panic. Because if my kid doesn't know his multiplication facts, maybe none of the kids know their multiplication facts, and I'm ramping and he can tell. And he's like, Mom, 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 you don't have to know your fives if you know your tens. I said, what? He said, you don't have to know your fives if you know your tens. I said, dude, I heard what you said. I don't know what you mean. Give me an example. He goes, okay, let's say that you don't know 9 times 5. Well, 9 times 10 is 90, and 5 is half of 10, so half of 90 is 45. There you go. And I was like, that is 9 times 5. Good heavens, does that work all the time? Give me another example. He goes, okay, how about 5 times 23? Not the example I'm thinking of, right? Like I'm wondering if kids know their single digit facts. And he's playing around with a pattern that could find 5 times 23. We all just do it quietly with me. What is 10 times 23? Just say it out loud. 10 times 23 is 230. Okay. If 5 is half of 10, then what's half of 230? Is that 115? Anybody want to check real quick? Like, is it almost a proof that you could say if I have 10 groups of things and it's 230 and I only need 5 groups of those things, I can just cut it in half to get 115. Is that 5 times 23? Y'all, in that moment, I'm aware that the mental actions my kid were using were not the mental actions my high school students were using. Like he was using relationships and logicking his way to an answer and very confidently. Whereas my high school students, they would sort of wait me out. They would wait until I gave them the rule and the steps and did some worked examples, and then they would mimic me. The mental actions were different from logicking his way, building new relationships, versus rote memorizing and mimicking. And in that moment, I wondered, could we create what he was doing? Because to be really clear, he had kind of done it on his own. It's not that he had newfangled teaching. He had same old, same old. For whatever reason, he was able to wander through life in the same low dose of mathematical patterns that we all run into. We all go through life, and there are these mathematical patterns, but they're in a low dose. And for whatever reason, that low dose of mathematical patterns was enough for him to pull together and create mathematical relationships and logic his way to solve problems. And then his brain's now stronger and he could create new relationships versus the mental actions of my high school students, which were all about rote memorizing and mimicking. And I wondered, could we create intentionally what he kind of did on his own in my high school students? But let me be really clear. I actually wondered if we could create that in me because I was doing the mental actions of rote memorizing and mimicking, not what my kid was doing. So I dove into the research. I read journal articles and research studies, everything I could get my hands on. And at the same time, I dove into my kids' classrooms and I literally said to my kids' teachers, may I enrich your students, which was totally code for, can I experiment on them? And I tried all that stuff. Because of my background in higher math, I was able to sift through a lot of less helpful research. And let me tell you, there's a lot out there and find that there is a real mathing way to teach. I'm Pam Harris, and I believe that math is figure-outable, and we can teach it that way. For the past 25 years, I've been helping teachers and leaders just like you get better results and have the confidence to reach more and more of your students, young or adult. Today, in this first session, I'm going to do two chunks with you today. In the first chunk today, I invite you to do three things. So first, I invite you to join me in a combined mathing experience because the story that I just told, which is totally true, had a lot of words and we did a little bit of math. But really, if we don't have a mathing experience that we had together, then I think we could be talking past each other. I could be using words and you could be hearing other words, and we might not actually know what each other mean. So I'm going to invite you to have a combined mathing experience with me today, one that we do together. So then when I say, "Ooh, those mental actions that you just did," you can go, "Well, I just did those. Like those are the mental actions I just did." Okay, that's what you mean when you talk about the mental actions of mathing versus the mental actions of rote memorizing and mimicking. So I want to have that mathing experience with you today. And then second, I'm going to teach you to see the shark. I'll tell you more about that in a minute. And third, I want to focus on how can we avoid the traps of the algorithms because they can trap. So how can we avoid the traps of the algorithms? Y'all, there is our lesson plan for this first chunk that we're going to do today. Thanks for having me. May I invite you in the chat right now with what I just talked about? Mom, you don't have to know your fives if you know your tens. Rote memorizing and mimicking versus logicking your way through a problem. And what I just talked about, what right now is either resonating for you or what do you have a question about? What's resonating for you right now or what do you have a question about? Will you throw that in the chat? While you do that, I'm going to share my screen. And sorry for those of you who couldn't see me earlier. Glad we got it figured out. Well, I'm a little jealous, Cynthia, but I'm glad. Everyone can have their own path as long as it works. Jamie, I might want to talk about that a little bit. I want to talk about that a little bit. I think that's a tricky statement that many people might hear one way and some people might hear another way. And yeah, let's keep talking about that. Organic way. I don't know. For some of us, I think organic didn't work very well. Thank you, everybody. Ooh, Abby, let's talk about how to get learners invested, especially when that right answer gets yelled out. Let's definitely talk about that. Oh, Jane, that's so interesting. I used that at the grocery, but didn't think about it in the classroom. Yeah, I wonder how true that is for many of your students, that they actually math sum outside the classroom. They get inside a classroom and all of a sudden they're supposed to do school math, and that's completely different than the mental actions they're actually doing in their life. And they think they're supposed to do school math a certain way. I wonder how true that might be for some of the learners that you guys work with. All right, you were typing while I was talking. Apologize for that. Robert, that's interesting. Estimates are often sufficient. We don't always need an exact answer. I want the best of both worlds. I want to be able to do both. I want to be able to estimate and get exact answers. So let's make that happen. All right, y'all. School versus real life math. See, what if school math and real life math could be the same? What if we could actually teach school math in a way that it is real life math? That's, y'all, math is actually figureoutable, and we can teach it that way. When I say that phrase, it's kind of my signature line. Math is figureoutable, and we can teach it that way. I want to bring school math and other math together. First thing that we're going to do now is I'm going to invite you to have a shared mathing experience. In fact, I'm going to quote John Sangiovanni, who is a math teacher educator, has done a lot of really good numeracy work. Yeah, in fact, I think I'm going to see him later today. Anyway, one of the things that he did, we run a free challenge. A few of our Katie Cheekwee's on today. A few of our people that are in our coaching group and our online workshops have know that we run a free challenge. You guys are all welcome to join our free challenge. I'll give you some information later about how you could do that. It just basically is 3 nights where I just get on and teach kind of like I am today about different topics. And during that, I always have a special guest. And John Sangiovanni was one of our special guests. And he said to me during his special guest, he said, "Hey, Pam, you know how there's the math you do at school and there's the math you do everywhere else?" And I said, "Hey, John, would you be interested to know that as a young kid and as a young teacher, there was the math I did at school?" And he's like, "Yeah, you know, and then the math you did everywhere else." And I was like, "No, there was the math I did at school. And that was it. Like, I did the math at school. I didn't, if I was out in the world doing math, I did it the school way." So some of you were talking about estimates and everything. I didn't do that at all. I followed the rules. I always wrote, memorize, and mimic. Yeah, you might look down on me right now. You're like, "That's really odd." I did what I was told to do. Like, that's what my teacher said math was. And so whenever I ran into a problem, I did it. Well, let's have a shared experience where we can all then come out going, okay, when Pam uses those words, mathing, not rote memorizing and mimicking, but the mental actions of a mathematician, when she uses those words, I've just experienced that together. Now we're all going to be sort of on the same plane. Before I kick that off, I'd like to tell you just a small research study. So a woman by the name of Anne Dowker, she's a British researcher. I got to meet Anne Dowker a couple of years ago when I presented at Oxford. 2 really cool things. I got to present at Oxford, totally Harry Potter land. It was amazing. But I also got to meet Anne Dowker, and I was able to say, "I quote your research study everywhere." It was really cool. Anyway, Anne Dowker went to professional mathematicians, so people who do mathematics for a living. And she said, "Hi, I have some school math problems for you here, and I'm just going to ask you to solve those problems. And then I might ask you how you did it. I'll sort of peer over your shoulder. I'll take note. I'll take note of how you solve the problems." She gave those mathematicians math problems to solve, and then she recorded how they solved those problems. What percent of the time do you think those mathematicians used one of our traditional algorithms to solve those problems? I mean, they're professional mathematicians, so maybe 50% of the time, maybe 75% of the time, 4% of the time. Almost never. Almost never. Y'all, what in the world were they doing the other 96% of the time? Well, as a student and as a young teacher, I had no idea. Now I do. And I'd like to experience that together this morning. Let's have a shared mathing experience. So I'm going to change my input really quickly. Can everybody see just a really blank screen? All right, cool. 0.3%, Mark. Okay, so we're gonna have a shared mathing experience. If you get to know me at all, you'll know chocolate is the thing. So I'm totally a chocolate fiend. Love me some good chocolate. I can even eat garbage chocolate, depending on the time. Today we're gonna talk about a little garbage chocolate. So can you picture a bag of M&Ms? See, I'm M&Ms. Now, if you're a Skittles person, you just totally picture Skittles. Yuck, but I'm gonna do M&Ms today. Can you picture the other day, a bag of M&Ms I had? There was a bag and it had 27 M&Ms in it. So it's not that little tiny one that's not even really worth it. It's kind of that bigger one. Can you picture that one? Everybody, yeah? Okay. So yum M&Ms. We get that 27 M&Ms in a bag. If we have that bag of M&Ms, has 27 M&Ms in it, how many M&Ms would be in 2 bags? Now, do me a big favor. Don't put that in the chat yet. So there you go. Halloween candy for breakfast. Everybody thinking, you're welcome to type it, but don't hit enter. Don't hit return. We don't want anybody to see your answer because y'all, we have this weird culture in the United States and Canada and a few other countries I've been in where we have given the misimpression that it's all about speed. So the last thing I want to do today is carry that on. So when you find an answer, you're welcome to type it, but don't let it show up until I say waterfall, until I say like go, until I say hit enter, hit return, whatever, and then we can kind of get everybody's answer. You're like, Pam, why not? Because the chances of your answer showing up on someone's chat before they've had a chance to let their mind really grind on the problem, the chances are high. And I don't want that to happen. I don't want to send the message that it's all about speed. You guys have all typed in a number out. You're like ready to hit enter. Everybody's finger on the ready? Ready, everybody? Hit enter. Go. How many M&Ms would be in? That was nicely done, everybody. Well done. Some of you even put in your strategies. Cool. So you're saying that you think it might be 54. I'm going to see if I can grab somebody's. Okay, so I'm going to use Mark. Mark said that he thought about, Mark, I'm going to put words in your mouth. You can tell me if I got this right. It's almost like he said, I'm going to find 2 bags of M&Ms. So I'm going to double the number of M&Ms. If you double the bags, you're going to double the M&Ms. But to think about doubling 27, he's like, 27 is made up of 20 and 7. So I'm going to double the 20 to get 40 and double the 7 to get 14. And 40 and 14 is 54. All right, so Mark, you can tell us, is that kind of similar to what you were thinking about? I'm in your mind. Excellent. Thanks. Super. I'm glad I read that well. Cool. Y'all, it would be totally better if I was calling on you. I apologize for not having a good bandwidth today. I'm in a hotel. So thanks for we're not going to do a whole lot of video today. But if I get your reasoning wrong, throw back at me. Maybe we can have one person unmute. I'm a little curious. Well, first of all, did everybody understand Mark's thinking? Does it make sense? It's almost like Mark said to himself, what is 27 made up of? Well, it's made up of 20 and 7. So I'm going to double each component part and then sort of stick those together. Okay, that makes a lot of sense. Did anybody say to themselves, I don't want to think about doubling 27. Ooh, icky. I'd rather think about doubling 30. Now, I don't know that I saw that in the chat. So now I'm going to look in the chat. Can anybody just like give me a thumbs up or something if you thought about doubling 30? I'm not seeing it as I scroll. Could you? We got a couple people. Let's see. Let's do, it's going fast. Michelle thought about it. Michelle, I'm going to try to get in your head. It's almost like Michelle said to herself, 27, icky. Ooh, but I can double 30. Oops, hang on, let me do it this way. 27 is like 30, but it's not really 30, right? It's 30 minus 3. So it's almost like Michelle said to herself, well, 30 doubled is 60, but I doubled too much. How much too much? Well, 3 2 times. What is 60 minus 6? Is that also 54? All right, Michelle, how did I do? Does everybody understand Michelle and, it looks like Katie? Does everybody understand Michelle and Katie and maybe Lauren's strategy? Yeah? Now, you could call that estimating, but y'all, we got a correct answer, didn't we? We got an exact answer. So the word estimating can go in there. Somehow we've kind of put this weird connotation to estimating. Maybe we'll bring that up a little bit later. I'll just suggest that what what Michelle did was say, I don't want to double 27. I'd rather think about doubling 30, but then I have to adjust. How am I going to adjust? Well, I have 33 too much, so I'm going to have to get rid of some 6 extra. Bam, I'm also on 54. 2 fine strategies. May I invite you to consider that the 2 strategies that I just intentionally pulled out are not the only ones that were happening in the chat. There were other ones in the chat, and I just lost my share, didn't I? Darn it. Hold on just a second. The 2 that, well, I'm going to try to talk and share at the same time. The 2 that I've got up there are on purpose. I pulled those on purpose, even though there were other ones that were happening. Those were the 2 that I was intending to share, because I'm going to suggest today that there's only a small set of major relationships that if we develop in our students and our heads, then we are mathing the way mathy people math. There's only a small set. I think it can feel like there's this vast, unknowable, unnumerable, unquantifiable, like anything anybody does is cool. And now anything anybody does is a great place to start. But there is a small set of major relationships that if we build in our students' heads and in ours, then we are mathing the way mathy people actually math. And these are 2 of the 4 major addition strategies. I'm just going to tuck those out of the way. We're going to come back and talk about that a little bit later. All right, cool. So we've got 1 bag of M&Ms, 2 bags of M&Ms. Some of you guys were thinking about Halloween. That was just the other day. What if I want a lot of M&Ms? What if I want 10 bags of M&Ms? So everybody thinking. Yeah, no, I'm not going to wait too long on that, because didn't a lot of you say, well, if you scale the bags times 10, then you would scale the M&Ms times 10. It's just 270. Now, maybe you've got some things you memorized about zeros and stuff, but we could maybe talk about that later. In fact, when we do the questions a little bit later, if somebody's like, yeah, how do you explain that to kids? You could ask me that later. Kids, I know your students are adults. So you could ask me about the place value later. But for now, I'm just going to use it. Now, that's something I want you to keep in mind. If your students have something, you don't necessarily have to dive in and dissect it. You can just use it. And then maybe then they get a little bit more interested in diving and intersecting, or in diving, and there was the word I just used, diving into it more later. But for now, we're just going to use it. All right, if that's the number of M&Ms in 10 bags, I'm super curious. Remember, wait to hit enter in the chat. I'm super curious how many M&Ms would be in 5 bags. So everybody thinking. You're welcome to type it, but don't hit return. Everybody thinking. And hit enter. All right, a lot of you are thinking that it might be 135 M&Ms. And I saw several people, I'll go with Rebecca because she's the one on my screen right now, say, well, Pam, if you have 10 bags of M&Ms, then you can just cut that in half to get 5 bags of M&Ms. Hey, it's almost like you were listening to my story with my kid. True story with my kid. So you don't have to know 5 times 27. If you know 10 times 27, can you just cut it in half? Then I'm super curious how you did that. So it looks like Rebecca said, if I'm going to cut 270 in half, then I'm going to think about cutting 200 in half and then cutting the leftover 70 in half. And if I had Rebecca on live right now, I would say, well, Rebecca, what is half of 200? Oh, that's 100. And what is half of 70? Do you know that? Guess what? If Rebecca used this strategy, then Rebecca knows half of 70. She might be like, yeah, that's 35. You might be thinking, Pam, my students, they don't know half of 70. And I will say, that's okay, because remember, I'm pulling out what Rebecca did. I'm not telling you how to do it. I'm representing Rebecca's strategy, and I'm asking, do you understand what she did? Cool. What do you know often what kids will say? That if they say, oh, I don't know half of 70, I'll say, well, then what do you know? And often students will say, well, I know half of 260. And then I'll say, what's left over? And they're like, well, there's just 10 left over. Well, half of 260 is 130. Half of 10 is 5. Here's the hard part. What is 130 and 5? Well, isn't it the same thing as 135? Bam. Both of these strategies end us in a place where the question is the answer. Let me just park there for a second. Pam, what do you mean by that? What I mean is we got to a place where we had 100 and 35, where the question here is, what is 100 and 35? And Rebecca was like, it's 135. If we do what a lot of kids do, and they're like, ooh, then we end up where, what is 130 and 5? It's 135. That's kind of a cool thing. Y'all, if you get to a place when you're solving where the question is the answer, you were probably real mathing. You were probably using relationships and connections to logic your way through the problem. Nicely done. That can be a hint for you as you're solving problems. You can be like, ooh, look at that. I just used the mental actions of mathing, because you recognize when you got to a place where the question is the answer. Let me juxtapose that with if you're using an algorithm. Think about any of our algorithms. You always turn everything into a bunch of digit problems. You line the numbers up, and then you do these digits, and then you do these digits, and then you do these digits. And then to say the answer, you read them off backwards, right? And at that point, you're almost surprised at the answer. You're like, who knew? Because you weren't involved in the sizes, the magnitudes of the numbers the whole time. But notice, both of these strategies, I'm thinking about 130 and 5. I'm pretty sure I'm close to the answer already, even before I add those together. And same thing down here. All right. Did anybody not think about cutting 270 in half with either of those strategies? Did anybody say to themselves, I'm thinking about 270 in half by using 300? Now, I haven't been able to keep up with the chat, so maybe you could smile at me. Did anybody use 300? Now, I'm going to use a move that I use a lot with students. Are you ready? Everybody look me in the eye. Could you? And I wonder how many of you just dove a little bit. You were like, I don't know, could I? And you started thinking about the numbers. And I'm trying to go back down to, could you? Is there anybody right now that didn't, but you're like, yeah, I think I could use 300. I'd actually be willing to let you unmute at this point. Is anybody willing to unmute? I don't even know if I'll be able to see you. My screen's so crazy right now. Everyone's like, no. Anybody?
I can if you want.
Okay, go.
So if you have 300 divided by 2, and that's too much, it's 30 too much. So you'd have to subtract 30 divided by 2. And so 300 divided by 2 is 150. And 30 divided by 2 is 15. So I do 150 minus 15, which is 135.
That's also 135. Was that you, Katie?
Yes.
I recognize your voice. Y'all, does that make sense? Is 300 minus 30, is that 270? Sure enough. And is 300 divided by 250? Now, in this point, you might be like, I don't even know. But could you think that through? Katie was pretty sure 300 divided by 2 is 150. 30 divided by 2 is 15. Everybody just take a deep breath for a second. May I invite you to consider some place value patterns that just happened? Not because you maybe even use that strategy, but notice that you might have, you can just notice now 300 divided by 2 is 150. 30 divided by 2 is 15. Can you see that 32, 32, 50, 15 tens, 15? Can you see those place value patterns? This is a way that we can have adult students, any students go, huh, look at that. It really is true that when you have times 10, there is that 0. And when you don't, there's not. Like there's this really nice place value pattern that's happening. And Marty, I see what you're talking about. And that's a very nice, what I would call a middle school strategy. It's a little bit more advanced. So I'm actually not going to run with that one today, Marty, but it's a nice one. Cool. All right, we have several ways of thinking about 270 divided by 2. I'm just going to tuck this out of the way. We might talk about that a little bit later. Cool. So far, we've got 1 bag, 2 bags, 10 bags, and 5 bags. You know what, you guys? When you go home today and someone says, you did a virtual math training, did they live through COVID? Just kidding. You know what? I get it. You're like, really virtual? Well, let me just offer to you. When they say to you, did you even learn anything? You could go, well, actually, did you know? You don't have to know your 5s if you know your 10s. And they're like, what? You go, I can find 10 times 20 or 5 times 27. Just multiply it by 10, cut it in half. Bam, you got 5 times 27. Y'all, when you go home today, you could be like, I now know how to multiply 5 times anything. All right, so if you don't learn anything else, you get that one thing. Everybody's at least, you're a little satisfied. There we go. Cool. Marty, when you do add a 0, can you multiply by 10 instead? Just a small little minor, just like multiply by 10. Okay, cool. So we got 1 bag, 2 bags, 10 bags, 5 bags. Y'all, I really like M&Ms. What if we wanted to have, well, actually, let me do this. What about 15 bags of M&Ms? 15 bags. Everybody thinking, everybody thinking. I wonder if there's anything out there that could help you. Everybody thinking about 15 bags. Y'all, in that moment when I put 15, how many of you said to yourself, oh, sure glad that 10 and that 5 are up there? Can we just add the 10 and the 5 together? And could you add those together? And I'm not even going to make you do that, but could you? Hey, when you go home today and somebody says, you did a virtual math training, did you even learn anything? You could go, did you know? I can find 5 times anything. Just multiply by 10, cut it in half. I can find 15 times anything. Just multiply by 10, cut it in half, and then add them together. Bam! Nicely done. We're not going to do it. But what if right now I asked you to find 16 bags of M&Ms? Could you just add a bag? What if I asked you to find 14 bags? Could you just subtract a bag? We're not going to do it, but hey, when you go home today, could you be like, you don't have to know your 5s if you know your 10s. You can find 5 times anything, 15, 14, 16 times anything. Thinking and reasoning, using relationships and connections, building your math brain at the same time. Cool, next problem. What if I were to ask you, I really like M&Ms, for 100 bags of M&Ms? Everybody thinking, throw that in the chat. Go, 100 bags of M&Ms. They'd already been eaten. Nice, Luella, I like it, I like it. All right, so if you have 100 bags of M&Ms, I wonder how you say this number out loud. I wonder how many of you would say that 2,700, which is totally correct. But I also wonder how many of you said, well, it's almost like we had 2,700s. 2,700? That number has 2 names. That's some nice place value that's kind of floating around in there. Cool. Next question. What if I were to ask you, that's too many bags of M&Ms. What if we only wanted 50 bags of M&Ms? So remember, you can type it, but don't hit enter yet. So everybody thinking 50 bags of M&Ms. I wonder if there's anything up there you could use to help you. I don't know. Everybody thinking. Does that sound? Are there some relationships that are feeling familiar? Go ahead and hit enter. What are you thinking about that? That might have been a little bit quick. Thank you for everybody for waiting. You guys are amazing. You might be the best virtual audience I've ever had that you're not hitting enter too soon. Thank you so much. I'm so impressed. How many of you said to yourself, well, Pam, we got 100 up there. Sure glad you had that 100. I'm just going to cut the 100 in half, cut the 27 in half. And when you did that, a lot of you said that was 1350. And then some of you are using, I'll tell you later about the app. Ask that in the question and answer. Some of you said, well, you could cut the 100 in half, but some of you were a little lazy. Efficient. Mathematicians often seek to be lazy, and we can call that efficient. How many of you said, well, Pam, I can cut the 100 in half, and I could think about cutting the 2,700 in half, and that might have felt like when we cut the 270. We're not going to actually do that. Did anybody, and I saw a few of you say, well, I can just kind of like almost cheat here. 5 bags scaled up times 10 is 50. Can I just, hey, look at that place value pattern. Do you remember earlier when I said that we could sort of talk about how to help kids learn the place value patterns? Well, one way to do it is to high dose them with those patterns. In other words, have kids actually cut the 100 in half. We're all really clear that this is the answer. And then notice that kids, sorry, you're adult learners, then notice this place value pattern. Notice that this 135 is now shifted over. And so we had to drop a 0 in that place. And when this 5 shifts over and we have to drop a 0 in that place. That's interesting. We can sort of notice those place value patterns. You might be like, Pam, our adult learners, they've noticed that place value pattern. Well, brilliant. Pull it out, let them notice it again, and we're going to continue to use it. All right, so we've got a lot of bags of M&Ms that we've been thinking and reasoning, mathing our way to. Too many bags of M&Ms. We're going on a diet. Right now, we only want 49. Everybody thinking. Ralu, I'm probably masking your name. That's a great question. Make sure you ask it later when we have the question time. All right. Let's talk about 49 bags. I'm going to wait here for a minute. I'm going to wait. I actually want you to find the number of M&Ms in 49 bags. So like, keep going. I'm going to stop talking. All right, let's get that answer out of the way. Just throw that in the chat so we can just kind of be done with that. All right, we've got a lot of 1,323, but I want to wait. Except, hang on, weren't a lot of you, when I put up, I'm going to actually get rid of that for a second. When I put that 49 up, everybody take a picture of your brain really quick. When I put the 49, how many of you were like, sweet, sure glad that 50's there? Huh? How many of you are like, sweet, sure glad that 50's there? Because you said to yourself, I'm just going to do 50 minus 1 to get 49. And so 1350 minus 1 is 1349. Right? Lindsay's like, no. Lindsay, that's not very nice. Tony, not very nice. What do you mean? Renee's giving me a thumbs up. Okay, I've got some yeses. I've got some nos. What do we do now? If we subtract a bag, how many how many M&Ms are in the bag? Are there, if we subtract a bag, we've got to subtract, hang on, let me represent this slightly differently. If we subtract a bag to get 49 bags, we've got to subtract all the M&Ms in that bag, which is not 1349. Okay. All right. So we've got to actually do some subtraction. Y'all, in the moment when you said to yourself, ooh, sure glad that 50's there, I'm just going to subtract a bag. That was real mathing. Nicely done. Now there is a potential at that point that you said to yourself, okay, I got to do this. Oh, I know how to do that. I learned this in 3rd grade. Let's see, I put that and I do this. And then you started to do all of the long subtract. And I'm okay if that's what happened. If this is what happened over here, that's okay. It's all, that's not a very good okay. Look, that's okay because y'all, look me in the eye. You've been doing that for a few years. Some of you longer than others. That's an age joke. Y'all, your brains learned that in 2nd, 3rd grade. And then you have been traveling, your brain has been traveling that mental path for a long time. You have done lots of problems like that. It makes sense to me that your brain would sort of kick into and travel that path again. I'm just going to ask, does it have to? Now, not everybody did, because I saw several of you have some different strategies. Could we think about 1350 minus 27 by subtracting 20? Now, I'm trying to keep track in the chat to see if I can find somebody who did that. I don't see anybody who did that just in my wandering up there. I'm going to go ahead and do this one. So could we? What is 1350 minus 20? Everybody thinking, is that just 1330? In that moment, did you find yourself going like eyebrows up and like, like you actually had to consider 1,350 minus 20? In that moment, may I offer to you, we need to have more of those moments with us and our students. I need to invite them into the magnitudes, the size of the numbers, not just a bunch of digits. So that might have been a moment for many of your students, they might go, now you might also find them going, I've always thought about that, but that's not school math. School math, I'm supposed to do it. And you were like, chuck that school math. Let's good job that you've always been doing that. Cool. So if 1350 minus 20 is 1330, but we still have to subtract 7, then what is 1330 minus 7? Everybody's thinking, that's our 1323. Nice. Now, I did see a few people in the chat use a different strategy. I'm going to use Martha. So Martha said that she could start at 1350 and subtract too much. She said, I'm going to subtract 30. Martha, there's no 30 in the problem. I'm just joking you a little bit here. Why would she subtract 30? It's almost like Martha said, 27, icky. I'm going to subtract too much. I'm going to subtract 30. When Martha subtracts too much, then Martha said plus 3. But Martha, we're subtracting. In Martha's chat, she said minus 30 plus 3. But why would she add? Now, if I could interact, because if we had bandwidth here today, I would hopefully Martha, often, the Marthas of the world, I don't know Martha, but often they will go, Oh, wait, maybe I'm wrong. Because I'm sort of questioning. Y'all, we need to start questioning right and wrong answers so that everybody gets a chance to rethink their thinking and know that they're going to justify their thinking. I wonder if Martha might say something like, but I subtracted too much. This jump was too big. It was only supposed to be 27 long. I jumped 30. How much too much? I think Martha would say 3 too much. That's why she had to add that. Oh, sorry, we landed on the 13. What did we say that was? 1320? Oh, we hadn't even done that yet. Sorry, 1320. So now here's the hard part. If we've jumped back 30, but we have to adjust because we subtracted too much, here, what is 1320 and 3? Everybody smile at me right now. Y'all, Martha just got to a place where the question is the answer. Whoop, whoop. Everybody give Martha some love. Like, nicely done. Like, minus 30 plus 3. What is 1320 and 3? Is that just 1323? Nicely done. I'm going to take just a second to note a few things for the advanced learners in the room. Notice that when I just represented these strategies, first, I represented 2 very specific strategies. There's only a small set of major strategies that if we can develop in our brains, we're mathing like mathy people actually math. These are 2 of only 4 of the major strategies. There's only 4. And these are 2 of them, and I pulled them out of you. Nicely done. Also notice that my 1350s line up, that my jump of 7 is longer than my jump of 3, that my jump of 30 is longer than the jump of 27, that the 1323s at least are trying to line up. All of that is very purposeful because what we're trying to do is create mental maps. I'm making a visual map because I'm suggesting these are the kinds of mental maps that mathy people have in their heads. What? Who knew? Several of you are saying right now, of course, Pam, everyone has that in their head. I invite you to consider, I did not. As a very successful high school math teacher, I did not. I didn't know it was a thing. Now I do. Now that I started to see what it could look like, my brain on paper could look like this. Bam! Once I know it's a thing, I can start working with it. I wonder how many of your adult learners actually have mental maps in their heads and thought they were cheating. They thought they had to actually do these tricks because they couldn't really figure out why the algorithms worked. Now, not everybody, but I guarantee some of your students think they're not good at math because they're not good at rote memorizing and mimicking, but they're actually mathing already, and we can capitalize on that. All right, I'm going to grab these 2 strategies. I'm going to drag them down out of the way. We're just going to put them right next to this. We're going to talk about those just a little bit later. All right, taking a little bit of time on this. Let me just get this. You guys just said that that was 1,323. When you go home today and someone says, you did a virtual, did you learn anything? You could go, you can find 5 times anything. 15, 14, 16, 49 times anything. How did you just find 49 times 27? Do you realize that's the problem that we just did? Did a lot of you find 100 times 27, cut it in half to get 50 times 27, and take away a bag? Bam. Mathing the way mathy people actually math. Everybody sit up tall. High five. Nice mathing behavior. Those are the mental actions of a mathematician. Let me put a finer point on it. When I said, hey, everybody, 49 bags, and you said, okay, you started looking at the table, you're like, ooh, I can just use the 50. I can just 50 minus 1, and then however you did the subtraction, I don't care. When you said to yourself, ooh, I can just, let me translate. You said, how can I use what I know to solve this problem? How can I use the relationships I've got? I've got 50. Bam, I can use those to logic my way through the answer. Those are the mental actions of mathing. Here's what you didn't do. You didn't go, I've seen that problem before. Oh, yeah, it's this problem. Ooh, and I know a bunch of steps. You didn't do that. You were mathing the way mathy people actually math. Okay, I'm looking at the time. I have to remember what time we're supposed to go to. Oh, we're actually not doing too bad. Let me throw out one more problem. Oh, I really want to read what people are putting in the chat, but I'm not going to yet. One more problem. Are you ready, everybody? What if I were to ask you, a little bit weird, hang in there. What if I were to ask you 2,673 M&Ms? I wonder how many bags. Hey, Abby, can I quote you someday? Can't emphasize that one enough. Sorry. You guys can read Abby's comment in a minute. Everybody's thinking about 2,673. How many M&Ms? Okay, everybody pause. Look me in the eye for a second. How many of you said to yourself, okay, how many of you almost found yourself on the ball of your feet? Like you're like, okay, it's almost like you're like, I'm ready to play the game. It's you know, like have the like that, like can you feel it? It's almost like you said to yourself, ooh, look at my screen. What do I know? 2,673. Hey. How many of you said to yourself, it's really close to that? If you said, ooh, it's really close to that, I wonder how close is it? Y'all, let me just translate. What you just said was, ooh, how can I use what I know to logic my way to an answer? Y'all, you're real mathing. Again, here's what you didn't do. You didn't go, have I recognized this problem? And do I know the rule that I learned in 3rd grade? And can I mimic those steps? Like you said to yourself, I wonder how far apart those are. And then grin at me. How many of you said, I sure hope it's 27? Is it 27? Bam. Well, if they're 27 apart, is that just one bag apart? And did you just get 99? And y'all, what problem did you just solve? Is that 2,673 divided by 27? Oh, yeah. Oh, yeah. Nicely done. Do me a favor. In the chat right now. 0, I feel terrible about how I just did those problems. 10, I feel amazing about what my brain was just doing with those problems. Throw that in the chat. Go. All right, we're kind of all over the place. That's interesting. Super curious about you guys that put 1s. Maybe send me a private chat. Let me know. I'm really curious. In an instant information world, I find myself giving up too soon. You know, we can work on that, Christy. We can work on that. That lack of stamina. May I invite you to consider that many of us in a school math sort of situation where math was about rote memorizing and mimicking, who wanted to do that stuff? Like it wasn't intellectually fulfilling. It didn't feed our souls. When we start realizing it's about our thinking, ooh, all of a sudden it becomes relevant. Even if the problems don't feel like it's something that we're ever going to do in our life, it's our thinking. That gives us agency and there's some interest in that. Oh yeah, that's nice. Imagine you could be from day one, it was a strength to be nurtured and shared instead of cool. We could go so many different places right now, but we're time. Yeah, let's do this. You just solved this cranky division problem, thinking and reasoning using what you know, mathing the way mathy people actually math. First thing we did today was have a shared mathing experience, so that when I say mathing the way mathy people math, the mental actions of mathematicians, you can go, okay, like I now know, I have an inkling. I felt what you're talking about. Y'all, this might feel to you like, whoa, like that was really kind of crazy, Pam. And there was stuff everywhere and all. May I invite you to consider, I wanted to have a large enough experience so that you could have a chance of getting an inkling. Don't worry if you didn't follow it all. Let me do one more quick thing. Because your students are probably not done at this point. They're trying to, I'm going to make some assumptions now, and you can tell me that I have this wrong. But let me go a little bit higher. What if I were to say, all right, we just found some good, lots of bags of M&Ms, nicely done. Could we graph these as ordered pairs? What if we wanted to graph those as points? What if all of the values in the left-hand column were the X's and all of the M&Ms were the Y's? What would that look like? Can everybody you don't have to sketch it. You might have your students sketch it, but for right now, can you just envision, would there be a pattern? Go over the bags, up the M&Ms, over the bags, up the M&Ms. Would there be a pattern? Everybody, if you think there would be a pattern, put a Y in the chat. If you don't think, they're just totally haphazard, points everywhere, put an N in the chat. Some of you think there might be a pattern. When I do this live with people, I can see you, I'll say, just like show me with your hands. So like, just do it in the air. Nobody can see you except for the people in the room with you, but like, just do, and I'll just guess. You know what I see most often right now? I see most often people going like this. or maybe this, like this, or maybe this. I just did that in 2 different slopes. And then I'll say, I saw one more person do this. I'll just throw out, is it a connected line or a bunch of points? Now we can have a discrete versus continuous conversation about the data versus the model that represents the data. That can be a nice segue into functional reasoning. What if I actually use technology a little bit to say, hey, here's a few of those points. What would they look like? Would they look like this? Everybody see those points? I totally just spit on my iPad. Oops, that's not what I meant to do. I was trying to wipe this. Okay, you don't care. So are those some, hey, look at that. There's that pattern that you guys were seeing. But notice it's a bunch of points. It's not the line that contains those points. Well, that's okay. Can we write the equation of the line that contains those points? Let's go back here. So we've got all of these bags, all these M&Ms. Could we now, what we've just been doing is a lot of connecting this way, and we sort of connected that way. But what if I wanted to connect this way? What if I wanted to say, if I just wanted to find the number of M&Ms given any number of bags, would that always be 27 M&Ms times the number of bags? I just did that really fast. I'm not suggesting that I built that in you right now. I would have done different things to have built that, but now I'm going to pull on, because you're adult learners, I'm going to pull on the fact that maybe we can, you've done this a little bit before. And then might I be able to say, okay, if that's true, that I could find the number of M&Ms with 27 M&Ms per bag times the number of bags, let's go look at that. And I can use technology to say, let's actually enter in a function where it's 27 M&Ms per bag times the number of bags. What would that look like? Bam. What do you think, everybody? And now we have the line that contains all of those points. Cool. Well, let's go a little bit higher math, and then later you're going to tell me where we should have stopped. What if I gave you completely unrelated data? Completely unrelated data, not related in any way. 1 to 28 and 2 to 55. Now, some of you might be like, Pam, I don't teach this stuff. I'm okay with that. In fact, I would almost prefer to hear from you. Before, we had 1 over 1 up 27, we got that point. Over 2 up 54, we got that point. Now we've got over 1 up 28 and over 2 up 55. If these are the first points that we just had, what are the second points doing? What does this look like? Is it if this was the first set of points, what does this one look like? Anybody want to type anything in the chat? What are you thinking about right now? If I had these points, is the 1 to 27, 2 to 54, where are the second points? This is super hard to type. Yeah, you're like, I don't even know. Like, you know what people mostly do if we're live? People will go like this. Everybody just look at me for a second. They'll just go, they'll just, yeah, a couple of you are like shifted up 1. Are you saying that if we know that that other line was y is 27 M&Ms per bag times number of M&Ms, but now you're like just shifted up 1? Yes. And what if I gave you completely unrelated data that was 1 to 26 and 2 to 53? What did those points just do? I'm doing this kind of fast. Did they just shift down 1? So could we say it's the same line we had before, but now we're shifting it down 1? And oh my gosh, high school math is FigureOutable. Bam. Sit up tall. What do you guys think? I intended to just take you through a task. Fun. I like it, Jill. I intended to take you through a task where we did really some pretty young multiplication into some pretty sophisticated multiplication, into graphing ordered pairs, into writing a function, into shifting that function. I'm suggesting that math is very connected and that we can teach it that way. If you are trying to teach your adult learner something, you might consider, is there a way where you could wrap back some of the things that maybe they don't have as much confidence into the content that you're actually teaching, and build in them the confidence to go, whoa, wait, I can think about this and then build it into this. I'm actually suggesting once we give people, everybody, an idea that math is figure-outable, it opens the world in a whole new way. And we can math the way mathy people actually math. All right, that was the first thing that we did today. Woo! Everybody, take a deep breath. First thing, we just math the way mathy people actually math. If nothing else, please remember the mental actions that you just did, the way you're feeling right now, and let that give you hope. Let it give you hope, and that now we can actually be communicating when we talk about the mental actions that mathy people actually do. All right, second thing we're going to, before we do that, I'm going to give you a second. A couple people are already putting some ideas in. That was delicious. I love it. Putting some things in the chat. Will you guys just, what now is resonating for you, or what now do you have a question about? Maybe only 2 or 3 words, or you could do a whole sentence if you want, but just put a couple of words. What's resonating for you now, or what do you have a question about? Go. Nice. Nice. Love it. Oh, brilliant. How can I integrate this into every topic? Right. That is the mission I'm on right now. We are integrating it into everything we as fast as I can. Woo! All right, second thing we're going to do today, even on a Zoom call, right? I know. Bam! I love that. Okay, second thing we're going to do today. What is the purpose of math class? Wait, I have to ask myself a question. No, sorry. I got ahead of myself. This is where I want to go, actually. Sorry. Second thing we're going to do today. I want to teach you to see the shark. Okay, I'm going to use a metaphor. So a little unmathy here for a minute. Here's the metaphor. Actually, before I do the metaphor, let me introduce it really quickly. I invite you to consider that there are at least 3 ways that we might have viewed or seen mathematics as a student that impact the way that we teach mathematics. There's at least 3 ways that I think that as we viewed mathematics differently, it then impacts. And I'm going to suggest there's 3 distortions, at least 3 distortions. And I want to sort of talk through those 3 distortions right now. To do that, here's the metaphor. So does anybody remember seeing these? If you were alive in the 90s, you saw this. This is called an autostereogram, or you might recognize it as a magic eye. So a magic eye is it's an image created with dots that then you shift the dots a little bit with a mathematical formula. And if you can make your eyes do the thing, then a 3D image pops out. Can anybody, don't put it in the chat if you can see it, but if you can see it, can you make a 3D image pop out of this? So everybody's looking, you're looking at the dots. The goal is to relax your eyes and sort of see through the image. The goal is to see if you can make the focal point be behind the image, and then there should be something that pops out. Now, Laura, a couple of people are like, Rebecca, they're like, I've never been able to make it work. It's okay if you can't make it work. Do you know there's actually a physical thing in some people that their eyes can't do it? So just, if you can't do it, it's okay. That actually, I have to remember to say that later about the metaphor. All I need for this metaphor to work is that you've tried. So if you've never tried to make one of these work, will you try? Okay, now everyone's tried. All I needed, I know, Kate, I'm sorry. So don't hate me right now. I just needed you to have tried. All just to have tried. So now everyone's tried, so stop hating me. Let me kind of help you out a little bit. I'm going to show you a video where I'm going to move some of the dots, and you'll see part of the 3D image. So it's a shark. So if you could see, if you could make the autostereogram work, you would see a shark. Now you're seeing parts of it here, and you're only seeing parts because I can't show you the 3D image because this is 2D, but you would see it would look something like that. Okay. So now everybody, the thing that was hidden traumatized me. Sorry about that, Luella. Everybody now stop trying to make it work. You've seen it work a little bit. You've seen the shark. So now can you just believe me that this is a shark? Okay, ready? Oh yeah, Laura. So maybe did anybody see the shark? We just want to put shark in there if you saw the shark. Jaws done. Yeah. Okay, so some people can see it. So don't get jealous right now. Some people can see it. The only thing I just needed you to have tried. Okay. All right. So everybody, now can we make an agreement? Everyone stop trying to see it. Stop trying. Stop. Stop trying. Stop, stop, stop. Everybody look at me. Here's the metaphor. Be in a math class. The teacher says, okay, it's time to teach subtraction. No. Multiplication of fractions. No. The quadratic formula. Like, I don't care. Whatever it is, it's the math you're teaching today. The teacher says, class, this is a shark. Now, here's how you shark. Can everybody see that there's kind of these wavy lines that are going down, these squiggles? Can everybody see these squiggles that are doing this? There's like vertical squiggles. And then can you see that there's like a horizontal kind of wavy thing about 2/3 the way through? Okay, so I need you to just don't try to see the shark anymore. Can everybody see there's these squiggles and these waves? So the teacher says, okay, ready, everybody? Today we're going to learn to do this math. This is a shark. Here's how you shark. You squiggle and you wave. Here's the first kid. Can you imagine that there's a kid in that class that goes, there's a shark? The kid can make the magic eye work. The shark pops out. They're like, there's a shark. Okay, okay. And the teacher goes, yeah, I'm not really sure what you're seeing, but I need to see the squiggles and the wave on your paper. And the kid goes, there's a shark. And the teacher goes, yeah, but for higher math, I'm going to need to see the squiggles and the wave. And I have to see your work to you got to show me your work. And the kid's like, there's a shark. Can you imagine that kid in that class right then might say to themselves, I'm not going to squiggle and wave. There's clearly a shark. God, math class, whatever. That's the first distortion. Second distortion is more like me as a kid. I didn't see the shark. When my teacher said, everybody, this is a shark. You squiggle and you wave. I said, weird. Doesn't really apply to me. It's kind of strange that you're asking us to do that, but okay. I'll squiggle, I'll wave. Oh, I got that right. Ooh, I did that fast. I guess I'm cool. I'll squiggle and I'll wave some more. Oh, I'm getting them all right. And I can remember today's squiggles and waves are different than yesterday's squiggles and waves. And I got that straight. And oh, I'm good at math. And I was so good at squiggling and waving, I became a math teacher. Never doing the mental actions of mathing at all, just squiggling and waving. Now stay in that same distortion. The distortion is that I believed that math was about squiggling and waving. And so I squiggled and I waved. Be a kid. Now I did it well. For whatever reason, I could rote memorize and mimic that stuff well. Maybe I'm a kid who believes that math is about squiggling and waving. I don't memorize well. And I'm like, ugh, math is stupid. Why do we squiggle and wave? That has nothing to do with my life whatsoever. I'm not good at this. Math is dumb. I guess I'm not a math person. So that distortion hits us hard. Be a third kid. Third kid in the math class. The teacher says, this is a shark. The kid goes, I want to see the shark. I'm excited. Help me see the shark. No. Stop with the squiggle and wave stuff. I want to see the shark. I believe I can see the shark. If you would just teach me how to see the shark. You won't. You just want me to squiggle and wave. But I'm not, if you just would help me see the shark, I can't memorize your stupid squiggles and waves. I guess I'll try. I guess everyone else can see the shark, and I guess I'm just not a math person. Totally just described my daughter. Okay, y'all got to stop trying to see the shark. Got to listen to the metaphor. Stop trying to see the shark. My daughter could absolutely math with the best of them when she could see the shark. She came home one day and she goes, ours is not to reason why, just invert and multiply. Mom, is division of fractions figureoutable? I was like, yes, it is. She goes, why won't my teachers help me understand division of fractions? And I'm like, sweetheart, calm down. They don't know. If they were like me, they have no idea why you invert and multiply. No idea. Be nice to them. Come home and I'll help you. I did a lot of math with my daughter. Yeah, interesting. Y'all, the distortion really comes out when those three kids grow up to teach. Because the first kid who could see the shark, the distortion comes out when the kid goes, that kid could see the shark, right? Grows up to become a teacher, wants to help everyone see the shark. That kid says, okay, everybody ready? This is a shark. Oh, wow. Only 2 of you can see it. The rest of you, oh, that's why my teacher did all that squiggle and wave crap. Okay, rest of you, sucks to be you, but you're going to have to squiggle and wave because the shark is clearly there. I don't know why you can't see it. I wonder how many of you had a high school or university math professor like that, who you're like, they could clearly see the shark, but they had no idea how to help you see the shark of mathematics. Yeah, that's the distorted part. If that's you, you're like, I've always seen the shark. Through research, the good news is I can now help your students actually see the shark. We now have ways to help your students really math. Just like you've always been trying to help them, we have now ways to help them to do that. What if you're more like me? You believed that math was about rote memorizing and mimicking squiggles and waves. If you were that kid, you grew up to become a teacher. This is me. I grew up to become a teacher. I'm like, okay, math is all about rote memorizing and mimicking. Whew. Let's see if we can get kids engaged. I'm going to tell a story to get them involved, and then we're going to have lots of rhymes and raps and mnemonics, and it's all about memorizing squiggles and waves. If that's you, I invite you. I can help you see the shark. And then we can help your student, and not, it doesn't even have to be and then at the same time, then you can help your students see the real shark of mathematics. Kind of like somebody said in the chat a minute ago, I'm now thinking about how can we do this with all math? I know that has been the road that I've been on for a while now. How can I help everybody see the real sharp of mathematics, do the real mental actions of mathing? And the good news is we can. If you were that third kid who's like, like somebody would just teach me, yeah, I don't really have to do much besides help you see the shark in the places you haven't seen it yet. You're one of the best teachers that we have because you've always known if you can help kids to actually see the shark, then everything makes more sense. I invite you to consider that across the world, we have a communication problem because as kids, we saw math differently. And for most of us who grow up squiggling and waving and never really mathing at all, we then perpetuate that myth. Even if we saw the shark and the only thing we know to do, in fact, if you were the person who saw the shark, I invite you to consider, you think that you saw the shark because your teacher taught you to squiggle and wave. Like when the teacher showed you those steps, for whatever reason, you were able to make mathematical connections. So then you turn around and you do that as well. You did that kind of on your own, but I invite you to consider it wasn't because they showed you to squiggle and wave. It's because there are inherent patterns in mathematics, and you saw those. Now we can help everybody see the real mathing actions of mathematicians. All right, that was our second thing. First thing we did today was have a shared mathing experience. Second thing, I just taught you to see the shark. Why? So that we can have real conversations with each other. Everyone I meet, I am always wondering and asking, what was your experience as a kid? How did you view math? Because it now impacts the way the conversation that we have totally impacts. Tom, we could talk about logs a little bit later if you want to add in the question and answer period. Danielle, same thing. Like pick a math topic. I did a ton of math where I got the 100% on the test and I had no idea what was happening. In fact, I'll tell you one other just really quick story. My 11th grade year, I was in a class called math analysis, which is really kind of what most people's trig or pre-calculus or whatever. So it was the year before calculus. And one unit, we did quadratics, parabolas. I took the test. I got the test back. I did everything correct on the test except one thing, and I got a 50%. Because every parabola that should have been like this, I made like that. And every parabola that should have been like this, I made like that. Like I just messed up one thing, x squared instead of y squared. That's it, the only thing. I did everything else, but I had no idea what I was doing. I had no idea what a parabola even was. That's the epitome of what I'm now going to call fake math. The good news is, whether you are in fake math or real math, we can now help everybody teach all kids to math the way mathy people actually math. All right, second thing we did. What is now resonating for you? Put one or two words. You can put a whole sentence if you want. What's resonating for you now as we talk about different perspectives, that distortions that can then distort the way that we teach math? Go. No wonder why I never liked fake math, Sue. You didn't like fake math, right? Squiggling and waving. Real math is amazing. Yes. It's what are mathy people? Adam, that's a great question. I'm going to suggest everyone is a mathy people, but some of us are terrible fake math people. Everyone is a mathy person, but we need to know what it is. We need to actually math. Then everyone can math. Many people are bad at fake math. Many people are bad at squiggling and waving. To be clear, who cares about squiggling and waving? We care about real mathing. Fake math is forgettable. I like it. I like it. Yeah, because real mathing is us. That's our mental actions. That's us literally building our brains, and it's so fun and cool and exciting. All right, I am looking at the time. So I said we were going to do 3 things, but here's the suggestion in a minute. Yeah. So if you were looking at your schedule, we could have ended in a couple of minutes, but I'm actually going to go a little over in this section, which will make this section a little bit longer and the next section a little bit shorter. It was already a little unbalanced. So now we're going to make them a little bit more balanced, the 2 sections. So I'm going to keep going. We're going to go for another 10 minutes or so. So if you need to stand up, kind of walk around or whatever, everybody ready for our 3rd point for our first thing today? So we math the way mathy people actually math. Now we're all mathy. We talked about how we can have a communication problem because we had different distorted ways of looking at math. The 3rd thing I'd like to do today, I want to introduce that by asking you, what is the purpose of teaching math? If you were to go start your own school tomorrow, would you teach math? You can create your own school, no rules, whatever, you can do whatever you want. Would you teach math? What would be the purpose in teaching math? I invite you to consider that many of us were in math classrooms where the purpose was to help kids get answers. Does that track for you? When you were in math class, the purpose was to help kids get answers to questions. If that's the purpose, then when a teacher says, tomorrow we're going to multiply numbers. Nope, we're going to divide fractions. Nope, we're going to solve equations. Like whatever, graph functions, whatever it is, whatever the math is, if the purpose is to get answers, does it make sense for a teacher to go, let's see, today I need to help kids get answers to these questions. Okay, what is the most foolproof, straightforward, no one's going to mess it up by the end of the class period? Everyone in lockstep is doing the same thing, circling their answer. Nobody struggles. They take it home. Parents recognize it. Bam. Whatever that is, that's how I'm going to teach math class. If the purpose is to get answers, that makes all sorts of sense. What if the purpose is not to get answers? Now, some of you put some fine ideas in there. I'm going to throw out my own idea. What if the purpose of teaching math is actually to develop mathematical reasoning? Now, I know that this is kind of busy, y'all, so hang with me. Ignore this for just a second. What if the purpose of teaching math is to develop mathematical reasoning? Now, I don't mean some fuzzy think better. I mean reasoning mathematically. That means I own content. I'm literally mathing. If the purpose of teaching math is to develop mathematical reasoning, then this comes into play. So I know this is busy. I'm going to take a minute to describe. I created this graphic to send several messages. Today, we're going to talk about one main message. Notice that they are ovals that are concentric. That means they are built on and they based on each other. That means that way over this biggest oval, way over here, that I want kids at the high school level reasoning about functions and relations and graphs and tables and transformations. If I want kids at the high school level reasoning about those things, that's built on and based on proportional reasoning. That's the land of the middle school. Now, I know I'm talking to adult educators, but I'm trying to put this into place for our traditional curriculums. That proportional reasoning is built on and based on multiplicative reasoning, which is the land of the 3rd, 4th, 5th, 6th, 7th grade teachers. That's built on and based on additive thinking, which is the land of the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th grade teachers. Notice that major overlap there. And that's built on and based on counting strategies. Now, you might say, Pam, this is really boring. First, kids count, then they add and subtract, then they multiply and divide, then they solve proportions, then they do that stuff no one understands. Okay, hopefully I got a chuckle there. But I'm actually suggesting it's not just kids getting answers to addition subtraction questions. It's not just getting answers to multiplication division questions. And it's not just solving proportions. It's literally helping kids build new strategies. It's literally helping them reason more complexly. It's literally helping them reason more sophisticatedly. It's building their brains so that they can grapple with more simultaneously. In fact, I'll put an arrow on here that the other thing that's growing here is simultaneity and sophistication. I'm a math teacher. Pardon my writing. Y'all, I use the word sophistication carefully. I don't mean posh. I mean thinking more complexly and more simultaneously. It's about the thinking. It's not about the person. I never describe a person sophisticated. It's the way the reasoning is happening. That's either less sophisticated or more sophisticated. So in this last section here, how do we avoid the traps of algorithms? Well, let's describe one algorithm and the traps that kids could get stuck in. Do you remember that we just solved the problem? How many M&M, why can't I say M&Ms today? How many M&Ms are in, 49 bags, right? We said we had to find 49 bags of 27 M&Ms per bag. Do you remember when we solved that problem? In fact, here, I'll just go briefly here. We solved that problem right here. 49 bags, 27 M&Ms in a bag. When you solve that problem, how many of you, oh, and I just lost it. It's 49 times 27. How many of you were thinking about 49 27s? 49 27s, you said to yourself, ooh, that's almost 50 27s. And we had 50 27s, or you could find it by cutting 100 in half. And then you could just get rid of a bag, right? You were thinking about 49 27s. Notice that in the algorithm, and I know you guys know this, but notice we tell kids not to think about 49 27s at all. We say, think about 9 times 7. Ask yourself, when you found 49 bags of M&Ms, did you think about 9 times 7, 7 times 9 at all? Ever? Lindsay says, nope. Heck no, says Mark. That's interesting. So one of the traps of algorithms is because we turn the problem into a bunch of digits, and at the very first we tell them work with the smallest, least consequential numbers of the problem. Could you imagine a kid who's like, okay, 49 times 27. All right, I'm going to teach me to see the shark. I'm going to find 49 27s. 49 27s. Wait, 9 times 7? 7 times 9? That's weird. Why do you, I'm not thinking about that at all. Oh, all my friends like sheep are just doing all those steps. I guess they're math people. I guess since that doesn't make sense to me, I guess I'm not a math person. Does that make sense? As soon as we turn the problem into a bunch of digit things to do, if a kid's actually thinking about the problem, in that moment, they're like, I guess I'm not a math person. That's noteworthy. So there's a trap of turning the problem into a bunch of digits. And then kids feel like they're not a math person because they didn't naturally think about the problem in terms of those small, inconsequential numbers. Go with me. Let's say you're a kid who's like, okay, that doesn't make any sense to do 9 times 7, 7 times 9, but that's what my teacher's telling me to do. I guess we'll do that first. Could a kid then do that problem? 9 times 7, 7 times 9. Let's see. 9 plus 9 is 18, plus another 9 is 27. Could they literally add up 7 9s or 9 7s and get this answer correct and get this answer correct and put that up there. And then the teacher could say, now do the next thing. And they could do that and do this down here. And then the magic 0 or the turtle lays an egg. And then I do the rest of the things. Then all of the single digit addition. When the kid just did all of those single digit multiplications, what reasoning were they using if they added up the numbers? They were answering a multiplication question. Is that multiplicative reasoning? We're doing multiplication problems. Is that multiplicative reasoning? Or were they adding up? Were they actually using additive reasoning if they were adding up all those numbers? That's interesting. So they could do all of those single digit multiplications and then all the single digit addition that you have to do and get this answer correct. And we could be like, yay, you're a multiplicative reasoner. We could allow them to move on in math because they're getting correct answers, thinking that they are reasoning multiplicatively because they're getting correct answers, but actually they were using additive reasoning the whole time. Anybody interested right now? Anybody right now saying to themselves, anybody realizing that we could get kids looking like they were successful at multiplicative reasoning when they were actually using reasoning in the level before? That's a second trap of the algorithm. It's probably the biggest one. The biggest one is I look like I'm successful over here, but I'm actually getting away with using less sophisticated reasoning. Let's do another example. When we found the number of M&Ms in 49 bags, let me go back here quickly. When we found the number of M&Ms in 49 bags, do you remember that we had to then, we said, well, we got 50 and we had to subtract a bag and we did some subtraction. Remember when we had 1350 and we subtracted 27 M&Ms? Remember that subtraction? So we did 1350 minus 27. Let's just take a look at that problem real quick. Let me do it right here. Oh, it's so messy. Let me go back here. So we did 1350 minus 27. Now we did it thinking about the numbers. You might have done it. A kid could say, oh, I know what I'm supposed to do. I should squiggle and wave here. So I'm going to, like, even if they do it correct and do all of that, notice the first numbers that they're asked to think about. Say they do it correctly. They get to 10 minus 7. Could a kid, they're supposed to be solving this subtraction problem, which is additive thinking. Could a kid say, all right, I've done all the things I need to do, borrow the sugar from next door or whatever that is, and now they've got 10 minus 7, and the kid goes 10, 9, 8, 7. Could they literally count back by ones to get this answer correct and then do this over here and do all of these digit calculations? And we're like, yay, you're an additive reasoner. When in reality, they used counting strategies the whole time. Again, two traps of the algorithms. First trap, we turn everything into digit problems. If a kid's thinking about 1350 minus 27, they're literally thinking about 1350 minus 20, minus 7, or minus a bit too much and adjust. If they're thinking about that, and we're like, no, just 1350, just do this. And now everybody just think about 10 minus 7. Did you think about 10 minus 7 at all during that problem? No. Did you borrow? Did you carry? No. There's none of that. So, and I can appreciate that you've removed carry and borrow and you've regrouped, but did you regroup at all here? Y'all, no. You thought about 1350 and you subtracted 27 and you weren't thinking about 10 minus 7 or 4 minus 2. And for sure then you, so good question. What do you do instead? Oh, no, sorry, you're asking that one. Never mind. I'm going to stop paying attention to the chat. Y'all, the problem is that we've given kids problems like this, and then we've said, turn everything into digits, think only about the digits, don't think about the numbers at all. And so then we've sort of nudged kids away from creating these mental maps. And if they were thinking about these numbers this way, and we said, no, think about it this way, then they feel like they're not a math person. Those are huge traps of algorithms. Let me go and do one more trap of an algorithm. What if we need kids over here in proportional reasoning? We need kids to solve a proportion. I'm just going to put some variables in there. And we say to kids, hey, to solve that proportion, let's cross multiply and divide. Yeah, that's a traditional algorithm for solving proportions. Would y'all just smile for a second and then say those words out loud with me? Ready? We're supposed to be building and using proportional reasoning, but we're going to cross multiply and divide. Multiply and divide. Ooh, those are right here. So in other words, we're asking kids they should be developing and using proportional reasoning, but we're giving them an algorithm where they can at best use multiplication and division. What if they do the long multiplication and division using the algorithm? They could be using additive thinking. And we get what we've gotten. What we've gotten is that we've got kids who are getting correct answers, but using less sophisticated reasoning than we could be developing and using. And we take kids who are actually thinking about the numbers and we say, don't think about the numbers, just do all this digit calculation stuff. And then they don't build their brains to think and reason. And we get what we've gotten. A mass communication problem where we think that math is about rote memorizing and mimicking when it's actually about doing the mental actions that you guys were doing all the way through this problem. The good news is we now know how to help us all reason, think and reason, math, the way mathy people actually math, and we can help you do it with your students. All right, everybody. We just had a shared mathing experience. I taught you to see the shark so we can now begin to communicate better about the way we viewed math as a kid and how it could potentially impact the way we teach math as an adult. And we just talked about how can we avoid the traps of algorithms. Let me just focus on those 3 traps. Promise we're almost ready for a break, you guys. Hang on for just a second. The less sophisticated reasoning trap, which is if we are supposed to be building this kind of reasoning, we don't want to get stuck using reasoning in the level before. We're trying to build proportional reasoning. We don't want to cross multiply and divide because we could be using additive reasoning in those algorithms. One of the other traps is that we turn everything into a digit problem. And now no answers are reasonable. And kids think they're not a math person because they don't get correct answers. And lastly, what is the definition of math? And if we think it's about squiggling and waving, rote memorizing and mimicking, then kids go, I guess I'm not a math person. And now their identity takes a hit. The good news is we are all mathy people when we math. And we can math the way mathy people maths. Y'all, how exciting is it that we can actually avoid the traps of algorithms? How can we avoid those traps? That is our next session. In the next session, we are going to talk about avoiding the trap of algorithms in a huge way by using problem strings. So let's take a break. I've got on the half hour, whatever time it is where you are, it's on the half hour right now. So at 1/4 till, we will come back and we will kick off and avoid the traps of algorithms using problem strings. All right, everybody, go take a break. Welcome back, everybody. Hope you're able to walk around a little bit, shake things loose. I certainly did. So math is FigureOutable, and we can teach it that way. Several people put in the chat some things like, okay, but then how do we do this? And we'd like to do this with more topics. We'd like to make math FigureOutable everywhere. I do too. And one of the ways that I've done that is I've created an ebook that lists the most important numeracy strategies, at least to me. I'm going to call them the most important because I've identified that there's only a small set of major relationships that mathy people actually use that lead to a small set of major strategies. And if we can own that small set, then bam, we're mathing the way mathy people actually math. So the first couple of pages are going to help you think about the difference between a strategy and an algorithm and a strategy and a model. And then it lists the major strategies for addition, subtraction, early multiplication, multiplication, division, the difference between a problem string and a number talk, and then also give you problem strings to try with your students. You can get that here. So we'll go ahead and throw, yep, we got two of them in the chat. Just put the link so you can either use this QR code or you could click on the link in the chat. I'm going to give you a minute to fill that out, send it in. We'll get you this free ebook sent right away. You'll also then be on my email list, which means you can find out all the ways that we're continuing to make math FigureOutable. I mentioned earlier that we run a free challenge. We usually do it about 3 times a year. This is a great way for you to find out about the free challenges that we run. I also do webinars all the time, keeps you up on our podcast. If you want to know more about what we do at Math is FigureOutable, this is a fantastic way for you to continue to learn how to make math more figure-outable. So grab that link, enter your name in there, and you'll get that ebook sent straight to you. I'll have another handout for you a little bit later in this presentation, but go ahead and get this one. We call it the major strategies, the most important numeracy strategies, because they really are super important. Oh yeah, thank you, Martha. Somebody asked about my text setup. A lot of people ask about how I do this. Some of you might present online sometimes, so you're sort of interested. I wrote it all down. Martha just put the link in the chat, so you're welcome to go there and learn more about how I'm sharing my iPad and what I'm writing on and the apps I'm using, and etc. Okay. So hopefully you guys had a chance to get your information put in there. Now I have a request. For the rest of my work with you today, I would like to focus on a way of teaching to develop these kinds of reasoning. But I also want to know what you're most interested in. So I am prepared to do problem strings to help build I think most of your students can count. So I'm not going to work on that. If you were pre-K through 2 teachers, then we would work on that. So that's not on the option today. But I wonder how many of your adult learners are actually stuck in counting strategies and haven't really built additive reasoning. So we can build additive reasoning. We've just built a bunch of multiplicative reasoning, but we could also build it with division. We could build proportional reasoning, or we could do some functional reasoning. So could you just vote by putting either additive, multiplicative, proportional, or functional? Again, the multiplicative that we would do, if we do it, is all about division. So additive, division, proportional, or functional. And I'm going to try to take note of what you put in the chat. Thank you for voting. Teach me how not to cross multiply. Okay, that's all of them. We could try to do all of them. The risk we would run is that we would get a little bit we would send the message that it's about speed, because we'd have to go a little bit faster. Okay, that gives me a pretty good, yep, you guys want it all. Let's make sure that we get proportional in there, but I am going to start with an additive reasoning string. String, Pam, what's a string? Well, you experienced one with me already. Let me just pop back to this. We did a series of problems in a certain order. To develop mathematical reasoning. And I had a goal. If I did this whole string with you, my goal would have been to shift functions. But while we did it, to shore up your proportional reasoning, because these are all equivalent ratios, 1 to 27, 2 to 54, 10 to 2, 7, all of these are equivalent ratios. What does that mean? It means that for every one of these entries, each one of the bags had 27 M&Ms in it. So we actually shored up baby proportional reasoning. I call it baby because we started with a unit rate. Grown-up proportional reasoning, or more advanced proportional reasoning, would start with a non-unit rate. So we'll do one of those in a minute. But notice, I got you reasoning about transformations of functions, writing a function, proportional reasoning. We also did a ton of multiplicative reasoning, right? Because we found 49 times 27. We also did division here a little bit. So we did a ton of proportional reasoning. And in the midst of all that, we also shored up your additive reasoning. I represented a couple of ways of doubling 27. That shores up addition. I represented a few ways of doing 1,350 minus 27. That shores up subtraction. The reason I just walked you through what we kind of did this morning is I invite you to consider that if you're going to dive in with your adult learners and do problem strings, start with something like this, where maybe not as long, because I spent a lot of time. I only get to see you guys this once, right? So I'm going to make sure that we had a really robust experience. But do something that looks, that feels sophisticated. Like, how many of you pretty quickly were like, whoa, you can multiply 5 times anything. Whoa, we just did 15 times, 14, 16 times anything. Like, you were instantly kind of like feeling like I was treating you with the respect you deserve as an adult. What I didn't do was start with problems that look like they're for tiny people, for young students. I did some things that, ooh, I like chocolate. Hey, let's have some chocolate. And pretty quickly, we were doing problems that had you feeling pretty sophisticated. So start there. With that in mind, I'm now going to say, once you've got your students going, well, that was okay. As an adult, I felt respected there. Then you could do an example of the additive reasoning string that I'm about to do. So again, I shored up some additive thinking in the midst of that problem string, even though it was ending up with functions. I got some additive reasoning started. If I do something like that with adult learners, which I work with all the time, I might then say, all right, it seems like a lot of you, when we got to this subtraction problem, kind of the only thing that you had was to line stuff up and do the algorithm. That's okay that you did, but would you be interested to build your brain? And like, you had access to this, you followed this. Do you want your brain to do this next time? You do. Well, let's do some additive reasoning work. Now I've kind of got their buy-in. Does that make sense to everybody? In other words, I'm suggesting, especially the older learner you work with, you want to give them the onus that you don't want to, even if you have some inklings they really need to work on additive reasoning, do it in the midst of making them feel pretty sophisticated. You're not faking it here. This is sophisticated thinking. Now you can say, ooh, would you guys be interested? And then they're like, yes. And even if they're only tentatively like, yeah, then you're like, okay, let's do some additive reasoning work. So let's dive in to a problem string, a string or series of problems intended to build additive reasoning in the learner's head. So first problem I'm going to give you is 8 plus 10. Not going to wait very long on that. What is that, everybody? And you're just going to say 18. I'm not even going to wait to see what you put in the chat, because I know that's going to go super quick. Even with your adult learners who struggle the most, probably 8 plus 10 is going to be pretty doable. So I'm just going to say exactly what I did with you. Not waiting long on that. You guys all know that's 18. But did you know that mathematicians often have in their heads mental maps? So I'm just going to kind of, that mental map could look like 8 plus 10 is 18. It could look like that. It doesn't matter if yours didn't. We're just going to throw that up there. Next problem. How about 8 plus 9? And then I'm just going to look. I'm not going to wait very long on that one. I'm going to ask, just maybe even have everybody yell it out. They'll yell out that it's 17. I don't really care how they did it. But then I'm going to ask, did anybody use the problem before to help you? Anybody use? And I'm going to watch. I'm looking for someone to spark. And if someone goes, then I'm going to go, ooh, tell me about that. And they're like, well, I mean, we just said that 8 and 10 was 18, but we only added 9. So we got to adjust back. And 1 back from 18 is 17. And then I'll just say, did that make sense to everybody? That if we know 8 plus 10, we could use that to help us think about 8 plus 9. You guys already, no, I'm going to do this really pretty quickly. Not quickly to give the impression it's about speed. Quickly to give the impression that we're not hanging here for too long. I know you guys are adults. Here we go. Next problem. Then I might say something like, well, I wonder if we could use the same, like, 53 plus 20? I'll let everybody think. Not very long. They're going to yell out that it's 73. Then I'm going to say, okay, so mental map 53. This should be a bigger jump of 20. And you guys are saying that that's 73. Cool. Anybody want to guess the next problem? Now, that's a very purposeful teacher move I'm going to ask you about in just a second. But I want everybody to sort of guess what the next problem might be. Now I've got students looking for patterns. Hopefully I have you looking for patterns. I don't know how to pronounce your name. Saktio just said that it could be 53 plus 19, but I'm actually going to suggest it's 53 plus 18. So notice there's just a moment where I'm just having a little bit of fun with you. It totally could have been 19, but it could also be 18. And then I'm going to ask, could anybody use the problem before to help you with this one? I'm going to look for somebody that smiles a little bit. Somebody who looks like, well, I just did something kind of clever. I'm going to ask that person to share. That person's going to say something like, well, if I know that 53, that's a 3, plus 20 is 73, but I only needed to add 18, that's a shorter jump back 2. What is 2 back from 73? That's 71. So we think that might be 71. Cool. Next problem. I wonder if I were to ask you for something like 145 plus 30. Everybody's thinking. Just ask people to say what it is. They're going to say it's 175. By the way, I'm doing this without a whole lot of feedback here. So you guys are going to tell me if I do something wrong. And then I'm going to be way over here at 145 plus a bigger jump of 30. Big jump of 30. And you guys, that's a big jump of 30. And you said that was 175. Again, anybody want to guess the next problem? Could it be 145 plus 27? Oh, yeah. Could anybody use the problem before to help you think? Mark, good question. Do I answer it now? Ask me in a minute, Mark. Ask me again in a minute. All right, so can anybody use the 145 plus 30 to help you think about 145 plus 27? Can you put in the chat, y'all, how could you use 145 plus 30 to help you think about 145 plus 27? What could you put in the chat since we're not having people unmute? What are you thinking about? So a lot of people are saying, if I've added that 30 already, but I only needed to add 27, I got to jump back 3, pop back 3. Here's the hard part. What is 175 minus 3? Is that 172? Is that right? 172? Cool. So it seems like I kind of gave you a problem that was kind of helped a lot of you do that one. You didn't have to use it, but you might have. I gave you a problem that I gave you a problem that you might have used to do that one. And I gave you a problem that some of you use to do that one. I wonder, what if I don't give you the helper? What if I only give you I just give you like this or this or this? If you were to look at the pattern that we've got going on so far, could you write a helper for a problem that's like, I don't know, how about 366 plus 198? What would be the helper? Like if that's the kind of clunkery problem, what would be the helper that you could write that could, if we followed the pattern? So remember, everybody, pause for a second, type it in, get ready to hit enter or return, get ready to hit it, but don't hit it quite yet. What could be the problem that could help you if you followed the pattern? What could be the helper that could help you to find 366 plus 198? That's so messy. Let me 360. Come on, Ben. All right, ready? Go. All right, a lot of people are thinking that you keep that first number the same, 366, and you're going to add 200. Well, let's talk about that. If I'm at 366 and I add, whoa, that huge jump of 200, I almost have to have like ... in there because I can't really show that. What is 366 plus 200? Is that 566? Okay, but we weren't supposed to. This one's 566. We weren't supposed to add 200. We're only supposed to add 198. Boop, got to pop back 2. Is that 564? And you think that might be 564. Cool. Who could put some words to why did you create the helper problem that you created? What stayed the same? What changed? How did it change? What kind of words could you put to that? Will you guys throw that in the chat? Wonder if this is a time where it might be easier to have somebody unmute, but go ahead and hit enter when you've got your ideas. Let's see, helper problems, 8 plus 2 is friendly. I wanted to use a friendly number. Zeros are easy to add. So something about the second number. Is that true? Did we do something with the second number and 0, everybody? Yeah? What was true about the first number, everybody? What did we do with the first number every time? Kept it? Did it stay the same? Every time if we look at these problems, we said to ourselves, 8 plus 10, 8 plus 9, 53 plus 20, 53 plus 18, 145 plus 30, 145. Like every time the first number stayed the same. And we looked at the second number and we said, ooh, I wonder if we could create something like you guys said, friendly. Somebody said close to 10 or 100. Was it always a little bit more than 10 or a little bit more than 100? I think we've lost an interpreter, so let me wait till, there we go. We got a screen back on. You good? Okay. Nice. So did we, every time we kept the first number the same, and did the second number, was it a bit too much every time? Because maybe the problem, when I gave you 198, did you say to yourself, ooh, what's a bit too much that's really nice? Because you didn't add 190, you didn't add 100, you added 200. Something that was a little too much that was nice. So that seems really helpful that we keep one number the same and add something that's a bit too much and then know that we could just adjust from there. Well, if that's true, what if I gave you something cranky? Like, what if I gave you something like, I don't know, 3.6 or 3 6/10 plus 1.9? Well, let me move that a little bit because I want to know what helper you would write. Like if this is the ugly problem, what would be the helper you could write that would keep the patterns going? What would the helper be that you could write that, whoops, that's not what I meant to do. Come on. Trying to shift that up just a little bit. All right, get ready to put that in the chat. What helper? Everybody typing in the chat, what could be your helper? Yeah, go ahead, hit it. Go ahead. Now, go ahead and use it to solve the problem. You guys are thinking that a nice helper might be 3 6/10 plus 2. What is 3 6/10 plus 2, everybody? Is that just 5 6/10? 5.6? Is that right? So let's see. If I've got 3.6 and I add 2, that's 5.6. You guys are checking me here. How can I use that to help me think about 3.6 plus 1.9? How's 1.9 related? And Janice, I'm okay that you thought 2.0. I'm totally okay with that. Is it just a 10th back? I'll tell you what, this is where you're going to run into where your students will say something like, just jump 1 back. And I'll say 1 what? And they'll say, and this is sometimes the naming gets hard. I might say, so if I had $3.60 and I was only supposed to add $1.90, but I added $2, and they're like, oh, it's a dime. And I might say, oh yeah, like a 10th. So I'm not going to get too worried about how they name it, but they might actually get the place value wrong here. That's okay. Just run with it. Like say 1 what? Ah, a 10th. So what is a dime back from 560? Is that 550? That 5's kind of messy. And so you're thinking that that might be 5.5. I wonder if you could, yes, it's great for understanding decimals. Nice. I wonder if you could use the same kind of reasoning, the same kind of pattern to help you think about a problem like, I don't know, 5.5 plus 2 3/4. Okay, take a deep breath. Don't get thrown into crazy fractionness. Remember the patterns we've just been using. Here's a number. We're going to keep it the same. Is that close to something? Is this close to something? Oops, I didn't mean to do that. What helper problem could you use if you, now there's lots of different ones, there's a few different ones that you could use. I want to keep the pattern the same. Well, the pattern you guys were talking about was, ooh, could we keep this first number the same? Oh, am I going too fast? Sorry. Keep the first number the same and then add too much. What's a really nice round number that's too much? A lot of you guys are saying 3. Okay, so if I'm sitting here at 5.5 and I add 3, what is 5.5 and 3? Sure enough, is that 8.5? Okay, but we weren't supposed to add 3. We were only supposed to add 2 3/4. We got to back up. How much do we have to back up? Throw that in the chat. How much do we need to back up, everybody? Yeah, just a quarter. We got to back up a quarter. Okay, here's the hard part. What is 8.5 minus a quarter? Throw that in the chat. Let's see, this was 8.5. Is that just 8.25? Now, in this moment, you might be like, I think we have to do more fraction work. And I believe you. Fractions are often so memorized with that's why cross multiply and divide is such a terrible thing, because they just mix it up with all the other, somebody said the other day, it's like playing algorithm roulette. Like you just like flip a coin and like whatever pops up on the roulette wheel. Oh, this time I'll cross multiply and divide. No, this time I'll multiply straight across. This time I'll find a common denominator. I think I'm going to invert and multiply. Like it's all the different rules get mixed up and mashed up because we're not really reasoning about the fractions. So I'm not pretending that I'm teaching you everything about fractions today. What I am suggesting is once we develop the strategy that we have going on here, that we can adapt it and use it with fractions and actually help teach fractions that way. We can actually help students, our adult students, learn more about fractions by helping them realize I can put 5.5 on a number line and I can think about 5.5 and 3 and what that looks like. And then I can adjust back and forth. And really here, I anticipate that we're thinking much more about the relationship between a half and a fourth. And we're not really finding common denominators. We're like thinking about the relationship between a half and a fourth. All right. I'm going to leave this problem string at that. This is a problem string, a string or series of problems where I gave you a problem. I pulled out your reasoning. I represented it, making it visible. Ideally, we'd have a conversation. Now, you haven't heard any conversation today because we're in this stupid format and I'm in a stupid hotel. So I apologize for that we haven't been able to go back and forth more. But ideally, I would have been asking you, not just in the chat, but you would actually be using words And at some point when someone would say their strategy, I would have another student, I would say, did you understand what that person said? Can you explain what that person said? I would be having more conversation in between the sets of problems. Notice that as we worked down the sets of problems, at some point I said, let's put some words behind what's going on. How could you describe what you're doing? And then I said, well, based on that, could you create your own helper? Could you create your own helper? Could you create your own helper? So at some point I gave you helpers. And then at some point, once we described it, then you started describing. Let me translate that. Y'all, it's almost like I'm saying, when you're walking down the street and you hit a math problem, could you say to yourself, what helper could I write? Or really, what do I know? Oh, I know that. I know 53 and 20. I can use that to help me think about 53 and 18. What do I know? Oh, I know 3.6 and 2. I can use that to help me think about 3.6 and 1.9. It's almost like you're saying to yourself, what do I know and how can I logic my way through to the answer? This series of problems is giving you a high dose of a mathematical pattern. Do you remember earlier today, I talked about how, for whatever reason, my son could go through life and hit a low dose of mathematical patterns and pull them together and create strategies like this. The good news is most of us just need a higher dose. And so this is an example. A problem string is brilliant, a brilliant way of teaching because I'm giving you a high dose of those patterns. There's about 4 major addition strategies. I've just helped you develop one of them. Now, I'm not suggesting that you own it yet. We would probably, many of us need a higher dose. We call this the over strategy. That if I add a bit too much, I can take off that little bit. And it's almost like, what do I know? Well, I know this too much, and I can just then adjust from what I know. Nice. Martha, I'm glad you like dosage. And Rebecca, I'm glad you like helper. I think those are very intentional words on my part. I know, Danielle, you asked about visuals. I think you specifically meant for the fractions. In this case, no. In this case, if a student really is like, I don't know, then I'm just going to take note of that. I'm not going to go off and then teach them all about fractions with the visuals. In this case, I'm going to go, sounds like we could do some more work on fractions. And then I'm going to do work on fractions. In this problem string, I'm going to kind of keep I'm going to use the open number line, just like I just did for this particular one. All right. Math is the aspirin metaphor. Oh, yeah. Yeah, that fits well. Nice. All right, y'all. What are you thinking right now about this particular problem string to build additive reasoning? What's resonating for you, or what do you have a question about this problem string? Throw it in the chat. Go. What are you thinking about this problem string? Go. Whole numbers to decimals. Nice. Many ways. And Ralu Rice, who I might be messing up your name, notice that there are many ways, but did you notice that I actually focused on one way? So I let you solve the problems any way you wanted to, but what I focused on was the strategy that, in this case, it was the over strategy. I focused on that. Y'all, that's one of the differences between a problem string and a number talk. In a number talk, in both of them, I'd let you solve the problem any way you want to. In a problem string, I'm more focused towards heading towards a specific relationship, a specific strategy. Notice how I nudged you to use my strategy. I let you do whatever you wanted, but I nudged you to use the over strategy in a couple important ways. One, I represented that strategy and only that strategy every time. Number 2, when I got down to asking you to write your own helper, I said, if you used the pattern that you're seeing up here, if you use the pattern, what would the helper be? So you could have solved, like when I got to 166 and 198, and I said, write the helper. I could have said, solve it any way you want. What I said was, write the helper. And then how could we use the helper? And the same thing down here. When I gave you that problem, if you were to use this pattern, what helper would you write? See how I nudged you into using the strategy, but I didn't force. It wasn't like, okay, everybody, mimic. I didn't say mimic. I said, what helper problem could you write? Yeah. Let me just look at a couple things that are happening in the chat. Cool. All right. So what we just did was really work on building additive reasoning. I'm not suggesting that one experience and we're done, but boy, with one experience, a hope that I would have, especially with your adult learners, is for them to go, let's do some more of that. That felt good. I did that. It might also be where they go, that's what I've always done. Are you saying that's legal? Do you know how many people that I talk to when they go, oh yeah, I could never get math. And so I had to come up with my own little sort of tricks and whatever. And when I'll ask them a problem, they'll do something like we just did. And I'll go, oh, you were actually really mathing. What you don't do well is fake math. That's okay. It's okay that you don't do fake math well. Sorry that we kind of forced you in school to think fake math was a good thing. But it sounds like you actually do real math pretty well. Nice. The number of adults that I've worked with who go, seriously? It's unbelievable how they're like, either it's usually one of those two. It's either like, wait, I was always doing those and you're telling me that that was okay? And I'm like, yes. And not poor, I wouldn't say it that way, but I would say it stinks that we kind of left you on your own to do that, but kind of cool that you could do it on your own. Hey, guess what? I can help you now do it intentionally and we can get better at it. Or people will go, wait, but I was never good at rote memorizing and mimicking. And they weren't good at coming up with their own. And I'm like, oh, that's okay that you weren't good at that. That's not mathing. That's rote memorizing and mimicking. Mathing, you just did. Nice. Those are the reactions that we're looking for. Then we need to continue to give them more doses. All of us need a higher dose than most of us got in school. Okay. Let me look at the time. I think we have time to do a division problem string. So let's do a multiplicative reasoning problem string where we're going to focus on division. And you're funny, like, Pam, you just told us that. It's okay, because I'm about to tell you that anyway. Okay. Nice, Jamie. I like it. What if I were to yogurt? Anybody eat yogurt? So we eat a lot of yogurt in our house. Can you picture a pack of those cups? You know, there's a cup of yogurt. Everybody gets one. You know, like you dish them out. You get one and you get one. At my grocery store, you're eating yogurt right now. Awesome. At my grocery store, you can buy a pack of yogurt. And it has those cups. And the pack that I buy has 6 cups. Can everybody picture that? 6 of those yogurt cups in that pack. Yeah, yogurt. Yum. If 6 of those yogurt cups are in a pack, what if I had 60 cups? I'm super curious how many packs I had if I have 60 cups. So remember, don't hit enter till I ask you to. So everybody thinking. Okay, go. A lot of you guys are thinking that might be 10. It's almost like you're saying that if you multiply the cups times 10, you would multiply the packs times 10. I just realized I'm showing my screen funny. Does that track for everybody? So you're saying that if I had 60 cups and I knew I had 60 cups in a pack, that I would have 10 packs. Okay, nicely done. What if we had not 60 cups, but we actually had 600 cups? I wonder how many packs we would have. And Danielle, I'll talk about pairs in a minute if you remind me. Ask me in the thing. It's a great question. Okay, flood it. How many? Excellent, everybody. That's 100. Good. So you're saying if I had 600 packs, 6 cups in a pack, that I would have 100 packs of yogurt. Nice. What if we only had 594 cups? That's all we got. But I'm really curious how many packs that would be. So get ready to explain your thinking. I think we've done well. Is anybody willing to unmute and tell me how many packs you think we'd have and why? I don't know how I would even see if you're willing to unmute. All right, just put it in the chat.
Sure.
How many? Oh, go ahead. Who's that?
Martha.
Martha, what do you got?
So I was thinking, well, 594 is 6 less than 600. And then I had a minute. I'm like, oh, right, that's 1 pack. So I'm going to subtract 1 pack from 100.
Which is? Keep going. Which is? Sorry.
Which is 99.
Which is 99. What do you guys think of Martha's thinking? Does that make sense to everybody? She's smart. I like it, Danielle. So it's almost like you're saying 594 cups divided by the number 6 cups in a pack would be 599 packs. Nicely done, Martha. Cool. Excellent. What if we didn't have 594 cups? What if we only had, actually we have more. What if we had 612 cups? We've got 612 cups, and I'm wondering if I have 6 cups in a pack, I wonder how many packs I'd have. So everybody thinking, everybody thinking. In a class right now, I would be saying, give me a thumbs up. I just realized I haven't done this all day today because I can't see you. I would be asking, give me a quiet thumbs up when you have an answer. That tells me how long to wait. I wait until I see most of the people with a thumb up. Yeah, so I can't see you guys right now, but go ahead and put it in the chat. How many packs do you think we'd have for 612 cups? All right, so I saw a bunch. I think Sarah said 102. Sarah, are you in a place where you could unmute and tell us how you got 102?
Yeah, I just saw that 600 cups is 100 packs, and if I have 12, that's 2 more packs, so I have 102.
Is that legal? Could she just add the 2 packs and 12 cups? Can she do that, everybody? Is that you're like, yes, I can. Okay, cool. So then once you have the 2 packs and the 100 packs, you're like, I'm just going to add the 100 packs plus the 2 packs because you added the 600 cups and the 12 cups. Cool. So 612 divided by 6, you're saying is 102. I already forgot your name. What was your name again?
Sarah.
Sarah. What do you guys think of Sarah's strategy? Does that make sense? Nicely done. Is it legal for Sarah to add this 2 and 12? Everybody smile. Absolutely. It's almost like I'm saying, can she use what she knows? Yes, she can use what she knows, and we're just going to add it. We'll keep it right there. So that's legal now for you to add things in the ratio table that might be helpful for you as we keep going. What if we had 615 cups? Wait, is that a typo? No, actually means 615. It's 615. Oh, I wish I could see if you guys are ready. Go ahead and throw in the chat if you think you know how many packs. I like your thinking, Tony. There's something about a half of a pack going on. Tony, are you in a place to unmute? Can you tell us what you were thinking about that pack? I mean, that half a pack?
Yeah, so I just looked and saw that each cup is, each pack is 6 cups, and then if you have, if you had 615 cups, that would be half of a pack,
Like
right?
how
Because
many?
it's only because we're adding 3 to the 612.
It's almost like you said, what's the relationship between 6 cups and 3 cups? That feels like a half.
Right.
That's like a half of a pack. So you're like, I think it's a
Mhm.
half of a pack. Nice. Because I think you saw that 3 there. Is that a way to represent that?
Not
go
in
away?
full cups.
Yeah, it's only half. It's not a full cup. It's only half of it. So you got it like there's a half there. So let's see. If we added 3 cups, then we're going to add that half of a pack. And so is that 102 and a half packs? Is that what you got, Tony?
Correct.
All right. What do you guys think of Tony's thinking? Everybody give her a big whoop. Tony, I know you can't hear them give you a whoop, but they're giving you a whoop right now. Okay, so you're saying 615 divided by those 6, that's actually 102 and a half. Hey, we got some decimal division going on. Thinking and reasoning. Nicely done. We're almost done. What if we had a lot of yogurt? What about 1,200 cups? 1,200 cups, how many packs? 1,200 cups, how many packs? If you're ready, maybe be thinking about how I might represent that. Like, how might I represent what you're thinking about? In other words, is anybody saying, well, 600 to 1,200, that's like twice as many. So I think that's like twice as many packs. Twice as many cups is twice as many packs. So that'd be 200. That'd be a way to do that. Did anybody also say to yourself, let me think about what else I might do. That's probably good. We'll go from there. Cool. So 1,200 divided by 1,200 cups, 6 cups in a pack. You're saying that might be 200 packs. Cool. Next question. What about 1,194 cups? Where does that go? 1,194 cups. I'm super curious if there's 6 cups in a pack, how many packs? Everybody thinking, everybody thinking. Okay, y'all aren't waiting anymore, so gotta wait before I say go. You are doing so well. It's okay. It's okay. I'm not upset. I'm not upset. A lot of people are thinking it might be 199. Hey, Jill, you just said something about one pack. Are you in a place where you could unmute, Jill? I should have been asked you guys to unmute earlier.
Sure. Yeah.
Go for it.
Well, God, sometimes you just do it in your head.
Sure.
You said 1,194, which is only one pack less than the 1,200, and that's 6. So you just subtracted 6.
We subtracted 6 here, so you're like, I've got to subtract a pack over here. Or another way that I could represent.
Is 6.
Sorry?
One pack is 6.
Yeah, it's almost like you said, if I did this 1,200 minus that 6 cups, then I've got to do this 200 packs minus that one pack. Bam, that 200 minus 1, that's 199. So you're thinking that might be 199. And what was your name again?
Jill?
Jill, thank you. Jill, hang on for just a second. Hey, guys, notice that Jill just solved this problem, right? But notice she was thinking and reasoning. Could we just for grins for a second, don't do this with your students, but just for grins, 6 goes into 1. 6 goes into 11. Yeah. Like, can you see right how this, if we turn this into digits, I want to just compare that to what Jill just did, where she said, well, I know what 1,200 divided by 6 is. That's 200. And it's just a pack less. It's just 6 less. So it's just a pack less. Notice how Jill was in the relationships, in the magnitude, thinking about 1,200 and 1,194, and the relationship of 200 and 199. Like, nicely done. I said to keep unmuted, Jill, and then I didn't even actually have you say anything. Sorry about that. Okay. Next problem. Last one of the string. What if we had 1,191 cups? Remember, don't hit enter yet. Mike says Jill is mathy. Everyone is mathy, right? As soon as they start to math, we're all mathy. We just need, when we math, we actually have to math. All right. Put in the chat. What do you think 11,000 or 1,191 divided by 6 is? I might not have given you enough time on that one. Ooh, 199 and eat 3 cups. 198.5. Look at those different answers. This is awesome, you guys. Cool. What are we down 3 here? And we already decided, let's see, if we're down 3, that 1194 minus 3 has got to be that 199 minus that half. And you guys are saying that's 198.5. Decimal division, thinking and reasoning, using what you know. Nicely done, everybody. And I like the, whoever it was that made sense out of eat 3 more. I like it because you're actually making sense of the problem. Okay, everybody, this is an example of a problem string to get us thinking about division, thinking and reasoning about division. I just want to note again what Jill and the rest of you did for these last couple of problems down here is you said, what do I know? Well, I know this, I know that. Can I work from there? Can I work from what I know using relationships? And in a big way, we just did the over strategy for division. Because can I get a bit too much and then go, that's a bit over to solve that problem? Can I go a bit over to solve problems that are just under it? That's like the over strategy. Remember, I told you there's only a small set of major strategies. The over strategy is a unique one because it fits. The over strategy is in addition, subtraction, multiplication, and division. The over strategy is almost everywhere. In fact, I can do it in solving proportions. Okay, we better move on if we're going to be able to get everything done. Yes, I can do over strategy with fractions. It's a little funkier with division of fractions, but yes, it can absolutely happen. Do I have one off the top of my head? I'd have to think about that. All right, everybody, what are you thinking about right now? You've just seen 3 examples of problem strings. Series of problems intended to create relationships and connections in the learners' heads so that strategies, models, and big ideas become natural outcomes. Let me change my screen really quickly and actually give you that a little bit here. We just did the string on the left. I added the fraction problem. We did not do the string in the middle. I had it ready in case we were going to. We did the string on the right, at the beginning of today. So a couple additive reasoning, a multiplicative reasoning. The string on the right, I followed it with graphing and then shifting the function. I kind of made a bigger string out of that. We just did this string, this division string. So I'm giving you some words here. It's a sequence of related problems. The teacher represents student thinking. Oops, sorry. The teacher facilitates conversation between the students. And it's all about that high dose patterning. Oh, for heaven's sakes, why are you doing that? My screen's being funky. All about that high dose patterning. One thing I want to be a little clear on problem strings. Do you know Howie Hua? Looks like Hua, H-U-A, Howie Hua. He's a big YouTube guy. He does some really nice stuff where he kind of helps explain some things in math. It's kind of super cute. One of the things that he did helped me understand how people were seeing problem strings that I want to kind of clarify a little bit. We were at a conference together one day and he's like, hey, you got a minute? And we sat down to chat and he said, why do some of your problem strings have extra problems? And I said, what? And he said, sometimes you do a problem string where there's problems that you don't need. And I was like, is he dogging my problem strings? Like, is he telling me my problem strings aren't good? I said, keep telling me what you mean. He goes, in order to solve that last problem, sometimes you have extra problems in the string. And I said, Howie, what do you think the problem string's goal is? And he said, well, it's to solve the last problem. It's a record of the work that you did to solve the last problem. And I said, oh, no, it's not. To be clear, everybody, when we just did this problem string, it wasn't so that we could solve that problem. It was so that we could build a lot of relationships and connections and build the over strategy. In other words, a problem string is an instructional technique. It's not a record of what you did to solve a problem or the steps to solve a problem. It's not that. It's a routine. It's an instructional routine for us to use as teachers to get us and our students reasoning better. It's to develop the relationships so that the strategies become natural outcomes. All right, I hope that kind of helps clarify a little bit. So let's do another example. You guys wanted to know what to do if you weren't going to cross multiply and divide. And that is a really, really good question. Luella, if you don't mind, yes, focus on the process and not the answer, but also notice we are getting answers. Sometimes people will say, wait, you don't want answers? And then that's kind of like almost, then they kind of turn off and won't listen to you. Notice we got it. We got the answers. We could focus on the process because we all got the answers. The answers took care of themselves. It's not that we don't want answers. It's that they are not the all important. We get the answers and we focus on the process because we're building those relationships in students' heads. Okay, so let's do an example of, here we go. So down the street from my house, there is a brand new pizza place. You ever want to get me? It's chocolate and pasta, chocolate and any kind of Italian. So today we're going to do pizza. And they happen to sell pizza by the slice. It's a little bit weird, but kind of go with it. It's worth it. It's yummy. The deal that they have is you can get 4 slices for $5. Can you picture that? Yeah, I know. I'm hungry too. The slices are kind of small because it's 4 slices for $5. They're kind of small, but they're super yummy. It's totally worth it. Can you picture that? 4 slices for $5. Okay. So what if I walk in and I'm like, I'm in the mood for pizza. May I please have some pizza? If they'll sell it to me, how much money would it cost for 2 slices? Go ahead and throw that in the chat. We're not even going to wait. Throw it and go. Yeah. I wonder how you're finding the $2.50. Well, I'm not going to wonder too much because I bet what you said is, well, if you cut the slices in half, would you cut the money in half? That makes sense. And $5 cut in half, that's $2.50 like a lot of you put. Yes? Okay, cool. So if you half the number of slices, then you half the money. That makes sense. Don't put it in the chat. Everybody thinking, or at least don't hit enter. Ready? What if I walked in and they'll sell it to me? If I walk in and they'll sell it to me, what if we only had $3? No, sorry. I only wanted 3 slices. 3 slices. I'd like 3 slices, please. 3 slices. 3 slices. Get ready to put it in the chat. Give everybody enough time to think on this one. I did not say go yet. It's okay. It's all right. We got happy people that are going. It's all right. All right, put it in the chat. Go. Thanks, everybody, for waiting. Okay, cool. So I wonder, Janice, I'm going to use yours. Janice just said that she figured out one slice. How many of you figured out? Don't put it in the chat because I want to be able. Don't. No more in the chat. But just smile if you figured out the price for one slice. I think a lot of you did. You said, one slice. In fact, did a lot of you say, well, I'm going to cut the 2 slices in half, so I'll cut that in half, and one slice would be 125. So just smile if you found the slice for one. And then I saw several people say that they then took that one slice, like Rebecca. Rebecca said, well, now that I've got the price for one slice, I can add that to the price for 2 slices. And if I add that 250 plus the 125, did a lot of you get the 375 that you had before? Did everybody understand Rebecca's strategy? Once Rebecca can find the price for one slice, she can add that to the 2 slices. Bam, we've got the price for 3 slices. Okay, that makes sense. Did anybody also find the price for one slice, but you didn't add it to the 2? Did anybody actually multiply? It was kind of looking, Luella, I don't want to forget yours in just a second. Did anybody actually say, no, that's ridiculous. Of course, nobody would have, Adam, that's ridiculous. You wouldn't multiply like 3-digit. Oh, look at what Adam did, you guys. Is that not too bad to multiply? Can you scale $1.25 times because $1.25, like the numbers, that's interesting. Like you can actually scale times 3 and scale 125 times 3, and Adam and Jill, nicely done, a little bit more multiplicative. Y'all, keep in mind that there is this idea of additive and multiplicative reasoning. And so I am always looking for, did you choose something more additive? Did you choose something more multiplicative? I'm going to make sure that I celebrate the more multiplicative in an attempt to get more of us thinking multiplicatively. Now, caution, if right now you're like, oh, I did the additive, that's not me dogging you. That's me saying when I realized I could think multiplicative too, I wished I'd had someone point that out. I wish I had somebody that was celebrating the more multiplicative way so I didn't have to figure it out on my own. Well, bam. My work's going to help do that. I'm going to help celebrate those more sophisticated ways of looking at it to kind of help us all get there. Now, somebody had said that, Luella said that she looked halfway between, that this 3 was exactly right in the middle of 2 and 4. So she wondered, what is exactly right in the middle of, and is 3.75, is 375 right in the middle? Nicely done. Now, because of time's sake, I'll just tell you that if we had time, I would ask this question. Can you always do that? So like algebra and higher teachers, if you're thinking about a function and you have 2 x values and you say, I know the x value of that one is this y, the corresponding y value of that x value is that, and the corresponding y value of that one is this, and then I throw some random number right in the middle, will its corresponding y value always be exactly in the middle of, I said I wasn't going to take time and now I'm doing it. Will it always be exactly in the middle? Like will this always be exactly in the middle of the 2 y values? If I choose a random x value exactly in the middle, will its y value always be in the middle? And I'm kind of curious. I'm looking to see what other, nice. So Danielle and Luella are saying only if it's linear. And then I'll maybe throw out, what if it's proportional? Does it have to be proportional or any linear? And let me just give you a non-example. So what they're saying is it has to be linear, because if I had an exponential function, notice how that y value wouldn't be exactly in the middle. Anyway, I just went way out of bounds. That was kind of fun though, because going out of bounds is fun sometimes. Oh, there it goes. Luella, I'll let you think about, does it have to be proportional or any linear? But I'm not going to answer that today. We don't have time. Okay, so nicely done. Great strategies, everybody. We got 4 slices of pizza, 2 slices, 3 slices, 1 slice. Cool. I wonder, what if I walked in and I wanted to have 10 slices? Hungry today. How much would it cost if I wanted to have 10 slices. So thanks for not putting it in the chat yet. Everybody thinking, everybody thinking. All right, throw it in the chat. Go. What do you got? 10 slices. All right. I obviously didn't give you enough time because I only see a few answers, so I apologize for that. If you were like still thinking about it, sorry about that. Then I would ask, and every time I'll get somebody that will say, well, let's see, I added the 4 plus the 2 plus the 3. What is that? 7, 9. And then the 1, if I add all those together, did you get the 1250? So we could do that. We could add all those together. Did anybody not do that? Did anybody not add those all together? So somebody said you could do 2 slices times 5. That would get you there. That's nice. Andy has a nice strategy. Andy said, well, what if you just multiply by 10 here? Ooh. Ooh, everybody give Andy an ooh. Ooh. Look at that nice times 10 pattern. And here goes that high dosing of those times 10 pattern. Y'all, I can't tell you how many times I've done this with adults. And adults have added up a bunch of stuff to get to the 10. And then somebody goes, well, could we just multiply? And then bam, we get that nice. Oh, yeah. Now, careful in that moment. When you have a student who goes, oh, God, I added, man, I didn't do the cool thing. You grab that right in that moment. You go, hey, do you have access to the times 10 thing? Does that make sense to you? Do you have access? Does your brain understand it? Then send your brain this message. Ooh, I want my brain to do that next time. Ooh, I want my brain to do that next time. When you see a strategy that you're like, oh, that's nice. In that moment, it could go one of two ways. We want to help catch all learners in that moment. If they go, oh, that was really nice. God, they're so smart. And I'm not because I didn't come up with it. In that moment, I want to grab that one and go, whoa, 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 whoa. Did you have access to that? Did your brain, you understand that? Do you want your brain to do that next time? Send your brain that message. Ooh, I want my brain to do that next time. Y'all type that in the chat. Ooh, I want my brain to do that next time. Literally everyone type that in the chat. Ooh, I want my brain to do that next time. Not just the ooh, all the words. Ooh, I want my brain to do that next time. I want that to be part of your psyche as you work with anyone you work with. In that moment, when they have access, send that message to your brain. Ooh, I want my brain to do that next time. Y'all, that is a really growth mindset. Ooh, that was clever. I want my brain to do that next time. Nice. Thanks for those of you who are willing to type that out. And it's okay if you didn't, but get that in there. I know, hopefully I said it enough. Go read the chat. Cool. Y'all, we're almost done with this one. What if I asked you, I walked into the pizza place. I'm like, hungry for pizza. Please, can I have some pizza? But today, all I have is $1. $10. I've got $10. That's what I have today, $10. How many slices could I get? Oh, nice, Janice. And that's real. I hope I get a chance to talk to me about that, to talk about that a little bit later. Now, several different ways that we could do this. I'm super curious. I'm just going to call on some random people. Luella, what were you thinking about to find? You said it was 8 slices. Luella, can you unmute? Are you in a place that you can unmute?
Oh, okay. So I took the 10 slices, which is 1250, and I just took away 2 to get to the 8. And then
You're like
50.
1250 minus the 250. That would give you the $10. So you got to do the 10 slices minus. Sorry, I talked over you, but I had to do that in order to. Is that what you did, Luella?
Yep.
And I didn't mean to talk over you, but I had to say it out loud or I wouldn't have been able to actually do the writing. So sorry I didn't mean to talk over you. Thank you very much.
Thank you.
Nice. Did anybody not do Luella's strategy? I saw a couple people in the chat. Who said they went from the 5? Somebody who said they went from the 5. Can you unmute? Donna, can you?
Hello, can you hear me?
Yes, ma'am.
Hello. So yeah, I thought about doubling that 5, so that times 2, and then so the slices would also be times 2.
If you double the money, then you double the slices. Nicely done. High five to you. Cool. And there's a couple different ways, but we're just going to kind of run with that. Good. All right, you guys. We've got lots of different pizza, lots of different slices. What if we only had $1? I walk into the place and I'm like, I'm so sorry. All I have is $1. If they'll give it to me, how much pizza could I get? Remember, don't hit enter. Everybody thinking. He'll smile at me for just a second, look me in the eye. I did this in a class with 7th graders. I know you teach adults, but these were 7th grade kids who were struggling. They were working really hard. 2 girls in the front. One girl kind of chuckled a little bit and she said, cut off the crust. And then her friend goes, nah, slide off the toppings. Y'all, what were they thinking about right now? Put that in the chat. What were they? You probably already typed your other thing. Were they thinking about the fact that for $1, you can't get a whole slice of pizza? Is that right? Brilliant. Like in that moment, I was like, yeah, less than 1 slice. I was like, sweet, that's awesome. Okay, so it's less than a slice. How much of a slice? All right, so now I'm going to let you guys think. How much of a slice could I get if I only had $1? If they'll sell it to me that way, if they will. Oh, but you weren't supposed to put it in the chat yet. Don't look at the chat if you're still thinking. Don't look at the chat if you're still thinking. It's all good. It's all good. Okay, y'all, because we're going to fry some more fish. Unfortunately, I'm going to go a little quicker here than some of you probably like. Could we do a couple things? Could we go from the $10 divide by $10 to get to $1? Could we also then divide by 10 here? And is that 8 divided by 10, which we can also write as 0.8? Did anybody say I could go from the 5 to 1 and the 4, divide that by 5? And is that 4/5, which is actually also equivalent to 0.8? So a couple different ways to do that. Last problem with this string. What if I asked you, I walked into the place and it's 42.50. That's what I got. 42.50. I want to know how much pizza I can get. 42.50. Could we find the number of slices? And oof, I'm running short on time. I'm going to give you a hint. Man, I got going and took more time than I intended. Maybe I'll well, shoot. I hate it when I'm running short on time. Did anybody, so if you have something to throw in the chat, feel free. Did anybody find the 40? Could you scale that times 8? Which means you scale the slices times 8. So 4 times 8 is 32. So 32 slices for $40. And then do we just need 250? We already had the 250 up here. So 40 and 250 would be 2. And the 32, is that 34? I did that really fast. Is that right? Somebody check me. A couple people are saying 34. Nice. You guys, what proportion did you just solve? We just solved a lot of proportions. But I gave you 4 to 5. And then I gave you 42.50. And you found that answer thinking and reasoning using what you know. So the short answer to what many of you just said, when you said, hey, Pam, how do you solve a proportion without cross multiplying and dividing? Well, we just did. Now, you don't have to do all this work to solve this proportion. Remember, we did a problem string to help build proportional reasoning. And in the process, we solved that proportion. We also solved a whole bunch of other proportions. But we solved that nasty nightmare, never thinking about 4 times 42.50 divided by 5 at all. We were scaling in tandem and building proportional reasoning. And the good news is we can. All right, y'all, that was fun. Hopefully you found that a little bit interesting. Y'all, we didn't do that one and we didn't do that one, but it's okay. All right, so we can develop mathematical reasoning using problem strings. What is a problem string? Well, it's a purposely designed sequence of related problems that help students mentally construct mathematical relationships, and it nudges them towards a major efficient strategy, model, or big idea. Here are some things to think about with problem strings. They're purposeful, and the problems are related. So it's not just some random bunch of problems. They're related, and the sequence, the order is on purpose. It's a mini lesson. It's not meant to be the only thing that you ever teach, though it's really pretty cool, and I use a lot of them. They're focused. The teacher chooses who shares either by circulating or asking questions. Now today, because of the format we were in, I kind of looked at what you wrote in the chat, but notice it's about choosing. Did you notice that I didn't take all the strategies in the chat? I let you solve it how you did, but then I chose the major ones. So this is the work that I've been doing for the past 25 years, is studying mathy people, how they actually math. And then building problem strings to help us all do that, which means you might use a cool strategy that's not one of the major ones. It's not the one that we're going to celebrate today. It might even be one of the major ones, but if I'm focusing on a different one, I'll let you use it. I might even walk back and go, that's really cool. We're not working on that one today. Today, I'm going to focus. It's not that I'm telling kids what to do. It's that I'm high dosing them with the patterns. One of the ways to do that is I choose who shares. And then I represent thinking. You've seen me draw a lot today. I'm making your thinking visible so that then it's discussable and take-upable. And then as you explain, my job is to draw out the relationships. Here's a few things that they're not. It's not all the problems listed at once. In other words, you might have seen these strings and go, ooh, I'm going to put those all on a paper. I'm going to hand them out. My students I'm going to send them home. They're going to do it for homework. No, not a problem string. A problem string is meant to be done just the way that we did it today. It's also not a group of unrelated problems. It's not where I directly teach the strategy. Here are the steps, and then I give you the problems to practice. That's not a problem string. I'm going to skip that one. It's not everyone shares. What that means is kind of what I said a minute ago. I'm going to let you do what you did, but I'm going to focus the work because I'm not just letting anybody share. I'm choosing which strategies get shared so that we move the math forward. I don't have students come to the board and model their own thinking. I might do that during a rich task or other teaching, but during a problem string, I'm going to represent the thinking. Why? Because notice, if I had you guys, I could have said, here, get on the electronic whiteboard and you can draw all over this. Notice it wouldn't look like this at the end. Like I wanted it to look like this. Did you notice I had lots of marks on here that I erased? Because I had a purposeful end look in mind. I wanted you to be able to use these relationships. If I had kept all that writing up there, it'd be way too hard for you to then pull out the important relationships for you to use for further problems. Notice every time that I did it, it wasn't because we weren't in person that I didn't have you come up and represent your thinking. I had a look in mind. Every time I wanted those number lines to be sort of shifted over where they are. Every time when I represented thinking, I had a look in mind, and so I'm representing student thinking. And then lastly, it's not a time for figuring out a student's crazy strategy or a crazy student strategy, whichever the case may be. What this last bullet really means is if a student says, well, I did this, and you're like, I'm not even sure if that would work every time, you can just say, I haven't seen that. Cool. And move on. Keep focused to what you're doing, then go to that student at a different time and be like, I'm sort of super curious. Let's talk more about that. But don't let it derail what you did during the problem string. All right, y'all. Math is actually FigureOutable, and we can teach it that way. I invite you to join me on the Math is FigureOutable podcast, where Kim, my co-host, and I talk all things Math is FigureOutable, from super young to older math. If you ever listen to and you're like, I'm not interested in that part, you can just skip that episode. We range the gamut, lots and lots there. I also invite you to join me on Math Strat Chat. So Math Strat Chat is a place on social media where I give a problem and people from around the world put in their strategies and comment on each other's thinking. It's a super place for you to get good problems. It's also a great place for you to build your own math thing. I used to just put out one problem string at a time, or sorry, one of these problems at a time. And then I noticed that I started doing more work and I realized, I knew this already, but it occurred to me that strings of problems, series of problems are more important. They give a higher dose. So y'all, I'll put out this problem Wednesday evening around 7 p.m. Central. And then the next week, I'll put one like it. I'll put the next problem in the string. And then the next week, I'll put the next problem in the string. So I'll just have you notice that Jennifer here put in her strategy, but she says, I remember a strategy from last week. She's noticing the string and she's getting a high enough dose that she's starting to be able to use those strategies in her own work. So Math Strat Chat, you can find, yes, it's on LinkedIn. It's everywhere. It's about to be on TikTok, which is a whole thing I haven't tried yet, but for now it's on Insta and Facebook, LinkedIn. Can't think. We're about to get on Bluehost, wherever. It'll be everywhere. Okay. I mentioned earlier problem strings. So I have problem strings that you can use for you because you teach adult learners. You're not going to want the K-5 ones. You're definitely going to be interested in the middle and high school one and the algebra and the advanced algebra one. These are numeracy into the content you teach. These are actual algebra strings, and then advanced algebra topics. There's some trig in there and some stat in there. That's where you can get those. To find out more about problem strings, here is a download for you. I gave you the download earlier with the Major Strategies ebook. This is specifically about problem strings, and you can get that at the link in the chat or on or at this QR code. So Martha's just put both of those links in case you didn't have them from earlier. Invite you to get both of them there about problem strings and about those major strategies. You can get those there. All right, I'm going to switch this. Well, maybe I'll leave that there. So I'll leave you with this. I'm going to have a little bit of an ending here, and then I'm going to answer questions. So I'll leave this up for just a second. Am I going to? Math is FigureOutable. You can get the link in the chat. Y'all, we started today where I told you the story about my young kid who I said, do you know your multiplication facts? Do you know your fives? And he was like, Mom, you don't have to know your fives if you know your tens. That kid sent me on a journey into research and experimentation and all the things, studying mathy people. I was ready to tell the world, I think algorithms are trapping kids into using less sophisticated reasoning than they could be developing and using. There are traps of algorithms. That should not be our end goal. I was all ready to tell the world that. One day, that same snot-nosed kid came home and he said, hey, Mom, will you teach me the long division algorithm? I said, dude, I'm ready to tell the world that algorithms are a terrible end goal, though, that we shouldn't go there. What? And he goes, yeah, you know how I've always just ignored what my teachers do, and I've always just logicked my way through problems, and I'm usually first done. I'm not first done anymore, and I'm taking a social hit. I was like, what? He goes, yeah, I've always just logicked my way through, done my own thing, and I've always been first done. I'm not done first anymore, and I'm taking a social hit. And I said, what are you doing? Y'all, he held up a paper, 50 long division of decimal problems. I said, you can reason through all of those? He goes, division of decimals is FigureOutable, Mom. This is my kid. I was like, whoa, okay. Y'all, in that moment, I didn't really know how to handle the disequilibrium. Like, I was ready to tell the world that algorithms were trapping kids. My kid says his friends are just doing this mindless bunch of steps and they're getting done before him. And he's like, doesn't want that to happen. What do I do? So in that moment, I kind of just didn't, I sort of set it aside. This is, now you know how I deal with conflict. And I said to myself, all right, I'll teach him long division and then I'll figure out my existential crisis of whether what I'm telling the world about algorithms. So in that moment, the only thing that I could think of was, in order for it to be division of decimals, this number inside had to be smaller than that number. Does that make sense, everybody? Then I would get a decimal answer if the number inside is smaller than the outside. So I said, okay, let me teach you how to do this problem. Honey, what times 8 is 6? So what times 8 is 6? And I'm all ready to prompt him with the decimal point and the 0 and the decimal point and all the things. Y'all, he looked at me and he said, 2/3. No, 3/4. Is he right? Y'all, what is 1/4 of 8? 1/4 of 8? Is that 2? What's 3/1/4 of 8? If I scale that times 3, scale that times 3, is that 6? Is 3/4 of 8 6? Yeah. I looked him straight in the eye and I was like, dude, I will not teach you long division. No, because you have been thinking and reasoning through all these problems, you've built your brain so that occurs to you. No, I'm not going to give you some cheap trick that now you can stop thinking. Nope, not going to do it. Y'all, that day I took a risk. I took a risk. I did not ever teach my kid steps of algorithms. All 4 of my children, he was my oldest, all 4 of my children never wrote, memorized, and mimicked algorithms. I took a risk. Wondered what would happen if we just helped them build the relationships that mathy people actually build. So they were so they were mathing the way mathy people math. I took a risk that day. All right, ready? Computer science, English major, computer science, almost landscape architect. All 4 of them now in their chosen profession can math the way mathy people math. Math did not keep them from doing what they wanted to do. It opened wide the doors for what they do, and they never algorithmed at all. Remember, my daughter, the 4th one, is the one who could not rote memorize. When her teacher would only say, mimic these steps, she failed. When she understood what was going on, she mathed with the best of them. Dyslexia, Tourette's, other things there lots going on with this one. I got one of the other 3s on the spectrum. Lots of stuff happening when they math the way mathy people actually math, not getting trapped in algorithms. They are successful mathers. Last part of the story. Number 3, almost 2 years ago to the day, was graduating from Brigham Young University with a degree in computer science. His last semester, he called me and he said, "Thanks, Mom." I was like, "For what? What do you got?" And he goes, "Mom, you'll never guess the class I'm in right now." And I was like, "Tell me." And he said, "It's called algorithms." I was like, "Oh my gosh, tell me more." And he's like, "Mom, all the kids in here that were like you, who didn't understand what was going on, they just rote memorized and mimicked their way through stuff, they're failing this class. Kids who are like me, we actually know what's going on because we were logicking our way through. We actually know what's going on. We can create algorithms." Y'all, I invite you to consider, we need kids who are mathing to create and understand the algorithms that computers need. We can math our way through mathematics because math is actually figure-outable. Y'all, thanks so much for joining me today. We have a half a minute for questions. Gosh, sorry, I meant to end a little bit earlier. Atlas, can you guys tell me, can we go 5 minutes over and answer questions?
Yes, that's totally fine.
Okay, so I know we had some questions earlier that I've already forgotten that I was going to answer. If I said, "Ooh, ask me that later," and I'm going to answer it, can you throw it back in the chat now? 6 divided by 8 example. Adam, I get that. Go do 6 divided by 8 long division and find out if it's 75.75. And then ask yourself about the fractional relationship between 3/4, 6, and 8. That would be a thing to do. Do you find your students can do the adding better than subtracting? Absolutely, until we subtract with them. And as soon as we subtract with them, then it actually is pretty even. But absolutely at the start, yes. What's your response to teachers and students who are resistant to this kind of learning? Yeah. So let's be clear. Almost everybody is resistant a little bit because this doesn't feel like the math class they were in. And so therefore it's a little uncomfortable. So my strong suggestion is dive into a problem string and get your learners, anyone you're working with, mathing, and then go, let's take a look. What did you just do? Anybody want more of that? And now you've got a little bit of their buy-in to do more of it. So yes, lots of pushback. I'll tell you though, everybody that I work with, what we expect and get is better results than before. There's no implementation dip or anything like that. Nope. Like soon as everybody's mathing, results just go up. Adult learners who might want to just use the algorithm. So Danielle, I taught high school. My high school students were very similar, especially the seniors that I were teaching that class. They had to pass in order to graduate, but it wasn't, like that. And many, if not most of the teachers that I work with are stuck in algorithms. So what do? I math with them. I do exactly what I did with you today. I get them mathing and then I go, what do you think about that? I get them mathing and now we can move forward when they're at least a little bit interested and a little bit confident. Oh, that's what you mean? And I can do that? Okay, let's do some more of that. Money was a go-to. Yeah. So Rebecca, I appreciate that anymore kids just swipe, right? And Venmo, and they don't. So I think that's all the more reason to use money. You're like, but Pam, I can't just use their experience. I know, give them experience. Like use money, not like hand them money, but do problem strings where you think about money and you expect them to get them better at money and math at the same time. Because I agree with you, we used to be able to use it because they were good at it. Now we need to get them good at it. So use it to get them good at it. I know I'm answering these really fast. Somebody asked me earlier, did I ask the question, anybody guess what the next problem is? Did I ask that on purpose? Or would I ask that with students, not just with teachers? So y'all, learners are all over the place. everybody in this workshop today, you're at different places in your journey. This doesn't mean smart and dumb. It means need more experiences with the thing we're doing, need less experience, ready for experiences with different things. If you're all here, I'm going to do tasks that everybody can enter and everybody grows. A way that I get these guys challenged during any problem string is to get them guessing what's coming next. It's a way to have differentiation. I knew Katie was going to be on today, who's about to do one of the sessions after this. Like, how do I keep her thinking? I'm going to ask her, what do you think my next question is? It's a way of differentiating instruction. Okay, teaching planning. What are the specific strategies? Yes, the answer to your question, Mark, is check out the ebook and then stay with Math is FigureOutable. Take one of our online workshops, join our online coaching group. There's lots of places where we can continue to help you to do Math Strat Chat and the podcast. We can help you to be clear. Thanks, Martha. Okay, people are trying to help with the 6 divided by 8. Great. I skipped over all that. Yep. Okay, I think we got him. Woo! With a minute to spare. Y'all, I am honored to be here today. Thank you so much. Go ahead.
No, I was going to say thank you so much for being here. Can people show Pam some love in the chat? This was amazing. Yes, that I have no words. Everybody seems so inspired to keep learning and to continue our own journeys. So it was fun to watch the chat. Thank you everyone for participating. Thank you again, Pam, for being here. Thank you, Martha, for being here. And I will you will receive resources in an email next week from Gail, but we have more for you today, so don't leave. I mean, you can leave and then eat lunch. Maybe it'll look like this, maybe it won't. I'm not sure, but come back at 12:45 using your flyer.